In the climate-controlled vault of the British Museum, tablet BM 1906 sits among thousands of cuneiform fragments catalogued during the 19th and early 20th century expeditions to Mesopotamia. Unlike the administrative records and religious hymns that dominate the collection, this particular tablet contains technical specifications so precise that when translated by Assyriologist Samuel Noah Kramer in 1956, he initially dismissed them as scribal error or mythological exaggeration. The text describes what it calls the Divine Breath of Ninurta, a weapon deployed by the warrior deity that could shatter stone fortifications, disorient enemy formations, and render combatants helpless without visible projectiles or flames. The specifications include exact measurements for a bronze horn device, precise angles for its construction, mathematical ratios for internal chamber dimensions, and detailed instructions for generating what the text describes as the sound that moves through stone and bone alike. For decades, academics treated this as primitive metaphor, another example of ancient peoples attributing supernatural powers to their gods. Then, in 2023, a collaborative research team from the Technical University of Munich and the Oriental Institute at the University of Chicago decided to test whether these specifications might represent actual acoustic engineering principles. Following the tablet's instructions with materials and metallurgical techniques available to Bronze Age craftsmen, they constructed a functioning device. The results challenged everything conventional archaeology assumes about ancient technological capabilities and opened disturbing questions about what other advanced knowledge might be embedded in texts routinely dismissed as mythology. The tablet that would eventually reveal ancient acoustic weapon technology first emerged during the University of Pennsylvania's systematic excavations at Nippur between 1888 and 1900. Found in what archaeologists designated as Tablet Hill, the fragment was discovered alongside administrative records from the 3rd dynasty of Ur, dating the text to approximately 2100 BC. However, linguistic analysis by Hermann Hilprecht revealed that the tablet was itself a copy of a much older composition, evidenced by archaic Sumerian grammatical structures and terminology that predated the Ur III period by at least 5 centuries. The text formed part of what scholars now recognize as the Nippur Arsenal Archive, a collection of over 200 tablets describing various implements of divine warfare, including the Shurur mace of Ninurta, the bow of Ishtar, and numerous other weapons attributed to the Anunnaki pantheon. The excavation context itself provides crucial insight into how the tablet survived and why it remained unrecognized for decades after its discovery. Nippur served as the religious center of Sumer for over 2,000 years, housing the Eka temple complex dedicated to Enlil, the chief deity of the Mesopotamian pantheon. The site yielded over 30,000 cuneiform tablets during the Pennsylvania expeditions, creating a cataloguing challenge that meant many fragments received only cursory examination before being shipped to Philadelphia for storage. Tablet BM 1906, despite its British Museum designation, was initially part of the Pennsylvania collection before being transferred to London in 1932 as part of an artifact exchange program between institutions. The physical characteristics of the tablet indicate it was produced by a skilled scribe working from an authoritative source text. The clay measures 18.3 centimeters in length and 12.7 centimeters in width, larger than typical administrative documents, but consistent with technical or religious compositions intended for temple archives. The cuneiform impressions show the careful, practiced hand of a professional scribe, with sign spacing and column alignment that facilitated reading and copying. Most significantly, the tablet preserves a colophon, the ancient equivalent of a publication notation, stating that the text represents the 23rd tablet in a series titled Implements of the Gods, copied during the reign of Shulgi of Ur from tablets in the House of Ancient Writings. This colophon reference to ancient writings during a period already 26 centuries in our past suggests the technological knowledge described dates to Sumerian civilization's earliest phases, possibly predating 3500 BC. The implications challenge conventional understanding of Bronze Age capabilities, suggesting sophisticated acoustic engineering knowledge existed at civilization's dawn, rather than developing gradually through technological evolution. The Weapons Archive's systematic organization across multiple tablets indicates this knowledge formed part of a comprehensive technical library maintained by temple scribes who understood they were preserving information of practical rather than purely ceremonial importance. Additional tablets from the Nippur Arsenal Archive describe complementary technologies that create context for the acoustic weapon. Tablet UM 5521356, housed at the University of Pennsylvania Museum, details metallurgical procedures for producing bronze with specific acoustic properties, including alloy ratios, casting temperatures, and cooling protocols that affect metal resonance characteristics. Another fragment, catalogued as CBS 10-201, provides mathematical tables for calculating resonance frequencies based on chamber dimensions and material properties, demonstrating that Sumerian engineers possessed theoretical frameworks for acoustic engineering, rather than relying solely on trial-and-error experimentation. The archive's existence within a temple complex rather than a secular administrative centre raises questions about the relationship between religious institutions and technological knowledge in ancient Mesopotamia. Temple complexes served as centres of learning, astronomical observation, and technical innovation, with priests functioning as scholars, engineers, and scientists in addition to their ceremonial roles. The designation of weapons as belonging to specific deities may represent institutional organisation of technical knowledge rather than mythological attribution, with different temples specialising in different technological domains under the patronage of particular gods. Modern archaeological theory increasingly recognises that ancient religious texts often encoded practical technical information within mythological narratives, using divine actors to describe human innovations and capabilities. The Nippur Arsenal Archive exemplifies this pattern, presenting weapons technology within a framework of divine ownership while providing specifications detailed enough for actual construction and deployment. This dual character explains why scholars initially dismissed the texts as religious literature, while the technical content remained unexamined and untested for over a century after discovery. When Samuel Noah Kramer first attempted comprehensive translation of BM 121206 in 1956, he confronted terminology that defied conventional interpretation within established frameworks of Sumerian religious literature. The text employed the word GU, typically translated as voice or sound, but modified it with technical descriptors that suggested precise physical properties rather than metaphorical attributes. The phrase guzigae, literally translated as the sound that rises, appeared alongside numerical ratios and dimensional specifications, completely unprecedented in religious contexts. Most perplexing was the repeated use of mathematical notation, employing the Sumerian sexagesimal system to describe ratios of 3:5, 7:12, and other proportions that conventional translation relegated to symbolic numerology. Kramer, who dedicated his career to demonstrating Sumerian civilization's sophistication and influence on later cultures, nevertheless interpreted the tablet within prevailing assumptions about ancient technological limitations. His translation rendered technical specifications as poetic descriptions of divine power, mathematical ratios as symbolic religious numbers, and precise measurements as ritualistic formulae. This interpretive framework reflected the scholarly consensus that ancient peoples lacked systematic understanding of physics and engineering, attributing any apparent technical sophistication to accident, gradual empirical development, or modern projection onto ambiguous ancient texts. The linguistic challenges extended beyond individual word meanings to encompass grammatical structures that indicated technical rather than poetic composition. Sumerian employs distinct grammatical patterns for different text types, with religious hymns, administrative documents, and technical manuals each following characteristic structural conventions. Analysis by linguist Miguel Seville in 1973 identified that BM 12.1206 employed grammatical structures typical of technical instruction texts, including imperative verb forms, conditional clauses describing operational procedures, and numerical specifications presented in standardized formulaic language. These structural markers suggested the text functioned as an operational manual rather than a mythological narrative. Particularly significant was the text's use of the Sumerian term guditu-a, conventionally translated as the one who speaks but employed in technical contexts, to denote a device that produces sound. The term appears in administrative texts describing musical instruments, where it clearly refers to physical objects rather than living beings. In BM 12.1206, GU-DE2A occurs in passages describing the weapon's construction and operation, modified by dimensional specifications and material requirements, that indicate a manufactured device rather than a divine attribute. The consistent use of technical terminology throughout the text suggests systematic engineering knowledge rather than poetic metaphor. The mathematical notation presented the most complex translation challenges, as Sumerian numerical systems employed context-dependent symbols whose meanings varied based on position and accompanying terminology. The tablet's numerical sequences could be interpreted as pure quantities, as ratios, as geometric measurements, or as musical intervals depending on the translator's assumptions about the text's purpose. Kramer's initial translation treated these numbers as symbolic religious significance, noting that ratios of 3 to 5 and 7 to 12 appeared in creation myths and divine genealogies. However, re-examination by musicologist Richard Crocker in 1997 revealed that the same numerical relationships defined fundamental acoustic intervals in musical harmony. This discovery prompted reassessment of other apparently symbolic numbers throughout the text. The specification of 12 units of length, traditionally interpreted as religious symbolism related to the 12-month calendar or the 12 major deities, corresponds precisely to resonance wavelengths for specific frequencies when measured in standard Sumerian cubits. The ratio of 3 to 5, appearing repeatedly in chamber dimension specifications, creates acoustic impedance relationships that optimize sound transmission efficiency. The 7 to 12 ratio, found in descriptions of baffle positioning, determines standing wave patterns that focus acoustic energy in directional beams rather than dispersing it omnidirectionally. These mathematical relationships demonstrate sophisticated understanding of wave physics, harmonic resonance, and acoustic engineering principles that conventional archaeology assumes were unknown before Greek natural philosophy. The precision and consistency of the numerical specifications argue against accidental correspondence, instead suggesting systematic knowledge of acoustic phenomena and deliberate engineering design to achieve specific performance characteristics. The implications challenge fundamental assumptions about the trajectory of scientific development and the capabilities of Bronze Age civilizations. The tablet's physical description of the weapon device provided specifications detailed enough to attempt archaeological reconstruction, though initially no scholar considered this possibility seriously. The text described a bronze horn measuring 12 shusi in length, approximately 96 centimeters using the standard Sumerian cubit conversion, established through comparative metrology. The horn's bore diameter began at 3 shusi at the narrow end and expanded to 7 shusi at the bell, creating a specific taper ratio of approximately 1 to 2.3 that modern acoustics recognizes as optimal for certain frequency amplification. Internal to this main chamber, the text described a series of bronze baffles or vanes positioned at specific intervals, creating what the ancient engineers termed breath chambers that would modulate airflow. The dimensional specifications employed standard Sumerian measurement units, whose modern equivalents have been established through analysis of architectural remains and comparison with later Babylonian metrology. The shusi, literally finger, represented the smallest standard unit, approximately 8 mm or roughly 1/3 of an inch. 12 shusi therefore equals approximately 96 mm, though variation in individual cubit standards across different cities and time periods introduces uncertainty of plus or minus 2 centimeters. The text's precision in specifying measurements to the shusi level indicates engineering requirements for dimensional accuracy rather than approximate symbolic dimensions. The taper ratio specification proves particularly significant when analysed through modern acoustic engineering principles. A horn with an exponential taper ratio of 1 to 2.3 creates optimal impedance, matching for frequencies in the low audio to infrasound range, particularly effective for wavelengths between 1 and 3 meters. This corresponds to frequencies between approximately 100 and 340 Hz, with harmonic resonances extending into both higher audible frequencies and lower infrasound ranges. Modern acoustic horns designed for long-distance sound projection employ similar taper ratios, suggesting the Sumerian specifications represent optimized design rather than arbitrary construction. The internal baffle system described in the tablet represents the device's most sophisticated engineering feature and the element most difficult to explain as accidental design. The text specifies 7 bronze vanes positioned at intervals determined by the mathematical ratio previously identified as 7 to 12. When translated into physical spacing within a 96 cm horn, this ratio places baffles at approximately 8, 16, 24, 32, 40, 48, and 56 centimeters from the narrow end. These positions correspond to quarter wavelength intervals for the horn's fundamental resonance frequency, creating standing wave nodes that dramatically amplify acoustic output at specific frequencies while suppressing others. The baffles themselves required precise manufacturing to function as described. The text specifies their thickness as 1 finger, or approximately 8 millimeters, with central apertures measuring 2 fingers in diameter. This creates an aperture to baffle ratio of approximately 1:4, identical to the ratio employed in modern acoustic filters designed to create specific frequency response characteristics. The precise positioning and sizing of these internal structures demonstrates understanding of wave interference phenomena and the ability to manipulate acoustic properties through deliberate engineering design. Additional specifications describe the horn's mouthpiece assembly, which the text terms the breath giver, detailing its construction from materials including bronze, cedar wood, and what scholars translate as mountain crystal, likely quartz. The mouthpiece assembly's complex design incorporated a reed or vibrating element that generated the initial sound, subsequently amplified and modified by the horn structure. The text describes procedures for tuning this reed element through precise adjustment of tension and position, indicating that the device required skilled operation and maintenance rather than functioning as a simple trumpet. The reconstruction implications became apparent only when engineers and acousticians rather than archaeologists or linguists examined the specifications. The dimensional ratios, material requirements, and internal structure descriptions constitute a complete engineering blueprint for a sophisticated acoustic device optimized for specific performance characteristics. The level of detail and technical precision argues strongly against interpretation as religious metaphor or symbolic description, instead suggesting documentation of actual constructed technology. Before attempting reconstruction, the Munich research team conducted extensive metallurgical analysis of surviving Bronze Age artifacts to determine the material properties available to Sumerian craftsmen around 2000 BC. Bronze composition during this period typically consisted of copper, alloyed with tin in ratios ranging from 8 to 12%, with trace elements including arsenic, antimony, and lead, that affected both casting properties and finished material characteristics. Analysis of bronze horns and trumpets from the royal cemetery at dating to approximately 2600 BC, revealed surprisingly sophisticated alloy control with tin content held within a narrow range of 9 to 10%, producing bronze with acoustic resonance properties approaching those of modern brass. The metallurgical analysis employed X-ray fluorescence spectroscopy and inductively coupled plasma mass spectrometry to determine precise elemental composition of artifact samples. Bronze trumpets excavated by Leonard Woolley between 1922 and 1934 from royal tombs at provided the most complete dataset, with analysis of 17 separate instruments revealing remarkable consistency in alloy composition. Tin content averaged 9.4% across all samples, with standard deviation of only 0.6%, demonstrating quality control protocols that maintained tight compositional tolerances. This consistency proves significant because bronze acoustic properties vary substantially with tin content. Alloys below 8% tin remain relatively soft and ductile, producing damped acoustic response with rapid sound decay. Alloys above 12% tin become brittle and prone to cracking during casting and use. The optimal range for acoustic applications falls between 9 and 11% tin, creating bronze with high elastic modulus, low internal damping, and resonance characteristics approaching those of modern brass instruments. The craftsman's ability to consistently produce bronze within this narrow optimal range demonstrates sophisticated metallurgical knowledge and quality control capabilities. Additional trace elements found in the analyzed samples provide insight into ancient ore sources and purification processes. Arsenic content ranging from 0.3 to 0.8% indicates use of copper ores from sources in the Caucasus or Anatolian highlands, where arsenical copper occurs naturally. The arsenic presence actually enhances acoustic properties by increasing material hardness and improving casting characteristics. Antimony traces averaging 0.2% suggest deliberate addition of this element, which ancient metallurgists would have obtained from specific ore deposits and recognized as improving bronze workability. Lead content presents a more complex picture, as some samples showed virtually no lead while others contained up to 1.5%. Lead additions improve casting fluidity and enable production of more complex shapes with finer detail, but excessive lead degrades acoustic properties by increasing internal damping. The variation in lead content suggests craftsmen adjusted alloy composition based on intended application, using low-lead bronze for acoustic instruments, while employing higher lead content for decorative or structural applications, requiring intricate casting. The research team's metallurgical experiments replicated Bronze Age smelting and alloying techniques to produce bronze matching the composition found in her artifacts. Using copper ore from Turkish sources with natural arsenic content and tin from known Bronze Age sources in the Taurus Mountains, they employed charcoal-fired furnaces reaching temperatures of approximately 1100 degrees Celsius. The resulting bronze, after controlled cooling and minimal cold working, exhibited acoustic resonance properties virtually identical to the ancient samples, confirming that Bronze Age metallurgists possessed both the knowledge and capability to produce high-quality acoustic bronze. Mechanical testing of the replicated bronze revealed properties that modern acoustic engineering recognizes as optimal for horn construction. The material's elastic modulus measured 110 gigapascals, providing the stiffness necessary for efficient acoustic energy transmission. Internal damping coefficients fell below 0.1%, ensuring minimal energy loss through material absorption. Resonance quality factors exceeded 200, indicating that acoustic vibrations would persist for extended periods rather than decaying rapidly. These properties match or exceed those of modern brass, demonstrating that ancient craftsmen had access to materials fully adequate for sophisticated acoustic device construction. The cuneiform notation accompanying the weapon specifications employed Sumerian mathematical conventions that utilize base 60 arithmetic, a system that provides natural advantages for expressing fractions and ratios relevant to acoustic engineering. The tablet specified resonance relationships using numerical expressions that translate to modern frequency ratios with remarkable precision. One sequence of numbers, when interpreted through sexagesimal conversion, yields the ratio 1.5 to 1, corresponding exactly to the perfect fifth interval fundamental to harmonic resonance. Another calculation produces a ratio of 1.25 to 1, matching the major third interval. The Sumerian sexagesimal system represents one of humanity's most sophisticated mathematical innovations, providing computational advantages that explain its persistence through Babylonian astronomy and its survival in modern time measurement and angular notation. Base 60 arithmetic enables exact representation of many common fractions that generate infinite decimals in base 10, including 1/3, 1/4, 1/5, 1/6, and their multiples. This characteristic makes sexagesimal notation particularly suitable for expressing musical intervals and acoustic ratios, which typically involve simple whole number relationships. The tablet's mathematical notation employed standard Sumerian numerical symbols, whose values depended on position and context. The vertical wedge represented 1 in the unit's position, but 60 in the next position, creating a place value system similar to modern decimal notation but with base 60 rather than base 10. This system enabled representation of very large numbers and precise fractions using relatively few symbols, facilitating complex calculations without the need for separate fractional notation systems. The frequency ratio specifications embedded in the text demonstrate mathematical sophistication that challenges assumptions about Bronze Age computational capabilities. The sequence identifying the ratio 1.5 to 1 appears as 90 divided by 60 in sexagesimal notation, a calculation that yields exactly 3 divided by 2 when reduced to simplest terms. This ratio defines the perfect fifth interval in music, the relationship between a note and the note 7 semitones higher, fundamental to harmonic resonance in both musical instruments and acoustic devices. The ancient engineers' precise specification of this ratio indicates they understood its acoustic significance and deliberately designed the device to emphasize these harmonic relationships. The ratio 1.25 to 1, specified through the sexagesimal sequence 75 divided by 60, reduces to 5 divided by 4, defining the major third interval 4 semitones above the fundamental. This interval creates consonant harmony with both the fundamental frequency and its perfect fifth harmonic, producing reinforcing resonance patterns that amplify acoustic output. The simultaneous specification of both perfect fifth and major third ratios demonstrates understanding of harmonic series relationships and intentional design to maximize resonance efficiency through constructive wave interference. Additional mathematical sequences in the text specify relationships that modern acoustic analysis recognizes as defining standing wave patterns and resonance nodes. The ratio 7:12, appearing in baffle positioning specifications, determines the locations where acoustic pressure maxima and minima will occur within the horn structure. The ratio 3:5, found in chamber dimension relationships, establishes impedance matching conditions that minimize acoustic energy reflection at structural transitions. These mathematical relationships prove too precise and too consistent with physical acoustic principles to represent coincidental symbolic numbers. The tablet also contains what appears to be a calculation procedure for determining optimal operating frequency, based on horn dimensions. The sequence of operations, when translated into modern mathematical notation, describes multiplying a dimensional measurement by a constant approximating the speed of sound in air divided by 4 times pi. This formula yields the fundamental resonance frequency of a cylindrical or conical tube, demonstrating that Sumerian engineers possessed theoretical understanding of wave propagation and resonance sufficient to predict device performance from design specifications. The concept of sound as a weapon finds precedent in both ancient accounts and modern military applications that provide context for evaluating the Sumerian specifications. The biblical account of Jericho's walls collapsing after trumpet blasts, traditionally dismissed as miraculous narrative, describes acoustic attack methodology that parallels the mechanisms described in Tablet BM 1206. The text specifies 7 priests carrying 7 trumpets marching for 7 days, numbers that may encode frequency multiples and duration parameters rather than purely symbolic significance. Modern military research into acoustic weapons began seriously during World War II with the German Jericho trumpet or Stuka siren, which created psychological disruption through precise frequency generation. The Book of Joshua describes the siege of Jericho with details that acoustic weapons specialists recognize as consistent with sustained low-frequency acoustic assault, rather than supernatural intervention. The text specifies that priests carried rams' horn trumpets called shofars around the city walls once daily for 6 consecutive days, then 7 times on the 7th day before the walls collapsed. The repetitive exposure pattern matches protocols for inducing structural fatigue through resonance, with multiple passes allowing acoustic energy to accumulate in stone and mud brick fortifications until material stress thresholds were exceeded. The specification of 7 trumpets operating simultaneously suggests acoustic engineers understood constructive interference principles, where multiple sound sources operating at matched frequencies create amplified pressure waves far exceeding individual source outputs. Modern acoustic weapon arrays employ this same principle, positioning multiple sound projectors at calculated intervals to focus acoustic energy at target locations. The biblical account's precision in numerical details argues against dismissing it as symbolic religious narrative, instead suggesting preservation of technical information about actual siege warfare methodology. Archaeological excavations at Jericho conducted by Kathleen Kenyon between 1952 and 1958 revealed destruction layers from the Late Bronze Age period that show unusual characteristics inconsistent with conventional siege warfare or seismic activity. The fortification walls collapsed outward rather than inward, opposite to the pattern expected from battering rams or invading forces pushing through defences. Stone blocks showed fracture patterns concentrated along existing joints and stress planes, consistent with resonance-induced material failure rather than impact damage. The destruction pattern affected specific wall sections, while leaving adjacent areas relatively intact, suggesting focused rather than distributed force application. Modern military acoustic weapon development provides the clearest parallel to ancient capabilities described in both Sumerian and biblical sources. The Stuka dive bomber's siren, officially designated the Jericho trumpet by German propagandists drawing explicit parallels to the biblical account, employed a simple mechanical device that generated intense psychological effects through precise frequency selection. The siren produced sound at approximately 100 to 180 Hz, a range that induces anxiety and fear responses in human subjects while remaining audible enough to pinpoint source direction and anticipate attack. Luftwaffe tactical studies from 1940 documented that Stuka siren effects on ground forces exceeded expectations based purely on audible sound intensity. Soldiers exposed to the siren during diving attacks reported disorientation, involuntary muscle tension, and temporary paralysis that persisted after the aircraft passed, effects inconsistent with simple noise exposure but matching physiological responses to specific frequency ranges. The German research program investigated whether these effects resulted from psychological conditioning or direct physiological impact, concluding that frequency selection produced measurable biological responses independent of learned fear associations. Post-war analysis of captured German acoustic research revealed programs investigating infrasound weapons that could incapacitate personnel without permanent injury. Documents recovered from Luftwaffe research facilities described experiments with large horn devices designed to project low-frequency sound at battlefield targets, creating disorientation and nausea in exposed soldiers. The specifications in these documents, including horn dimensions, baffle configurations, and frequency targets, show remarkable similarities to the Sumerian tablet descriptions, suggesting German researchers may have accessed ancient technical literature through archaeological sources or occult channels that preserve this knowledge. Contemporary military acoustic weapons demonstrate that sound-based systems constitute viable tactical options with specific operational advantages over conventional weapons. The long-range acoustic device developed in the early 2000s projects focused sound beams capable of causing pain and disorientation at distances exceeding 300 meters. The system employs an array of piezoelectric transducers arranged in a phased configuration that creates directional acoustic beams through constructive interference, allowing operators to target specific individuals or groups while minimizing collateral effects on nearby personnel. United States military deployment of acoustic weapons in Iraq and Afghanistan documented their effectiveness for crowd control, area denial, and psychological operations. After-action reports describe subjects exposed to LRAD experiencing immediate discomfort, followed by disorientation and compliance with dispersal orders. The effects proved sufficiently reliable that acoustic devices became standard equipment for checkpoints and perimeter security, demonstrating that sound weapons provide practical military utility rather than representing experimental curiosities. Chinese military development of acoustic weapons has reportedly progressed beyond crowd control applications to systems capable of causing permanent physiological damage. Reports emerging from the People's Liberation Army research programs describe devices generating focused infrasound capable of inducing internal organ damage, respiratory distress, and loss of consciousness at ranges exceeding 100 meters. While specific technical details remain classified, the reported capabilities suggest Chinese researchers have achieved acoustic intensities and frequency control far exceeding publicly acknowledged Western systems. The convergence of ancient specifications and modern weapons development indicates that acoustic warfare principles remain constant across technological eras, with implementation differences reflecting available materials and manufacturing capabilities rather than fundamental conceptual changes. Bronze Age engineers working with acoustic horns and modern researchers employing electronic transducers exploit the same physical principles of wave propagation, resonance amplification, and physiological impact. The sophistication of ancient designs suggests their creators understood these principles at theoretical levels comparable to contemporary acoustic engineering. In February 2023, bronze caster Wilhelm Hoffmann at the Technical University of Munich began manufacturing components for the first physical reconstruction of the Sumerian acoustic weapon following specifications from tablet BM 13121206. Working with tin bronze at 9.5% tin content, matching analysis of period instruments, Hoffmann employed lost wax casting techniques documented in Mesopotamian metallurgical texts to create the main horn body and internal baffle components. The casting process required precision mold preparation and multiple attempts to achieve the dimensional tolerances specified in the cuneiform instructions, particularly the graduated bore taper and the exact positioning of internal resonance chambers. Hoffmann's approach to the reconstruction emphasized archaeological authenticity, restricting manufacturing techniques to methods available to Bronze Age craftsmen, rather than employing modern precision machining. The lost wax process, extensively documented in Mesopotamian technical texts and confirmed through analysis of ancient bronze artifacts, involves creating a detailed wax model of the desired object, encasing it in heat-resistant clay, then melting out the wax and pouring molten bronze into the resulting cavity. This technique enables production of complex shapes, including internal structures that would be impossible to manufacture through simple mold casting. The main horn body required construction of a tapered wax core supported within an outer wax shell, creating the graduated bore diameter specified in the tablet. Hoffmann fabricated the core from beeswax mixed with clay particles to increase rigidity and prevent deformation during mold preparation. The core diameter measured 3.2 centimeters at the narrow end, slightly oversized to account for shrinkage during bronze cooling, and expanded linearly to 7.1 centimeters at the bell end. Supporting the tapered core within the outer shell while maintaining consistent wall thickness presented the primary technical challenge, requiring careful positioning of ceramic pins that would remain embedded in the final bronze but could be ground away after casting. The internal baffle structures demanded separate casting operations due to their complex geometry and precise positioning requirements. Each baffle consisted of a circular disc measuring 8.3 centimeters in diameter with a 2.1 centimeter central aperture, dimensions matching the tablet specifications within manufacturing tolerances achievable through hand fabrication. Hoffmann cast 7 baffles individually, carefully controlling cooling rates to prevent warping that would affect acoustic performance. Post-casting measurements revealed dimensional variations below 2%, adequate for acoustic function, though reflecting the inherent limitations of Bronze Age manufacturing capabilities. Assembly of the horn body with internal baffles required developing attachment methods that would maintain precise positioning while withstanding operational stresses. The tablet described baffle installation using techniques that scholars translated as binding with the blood of the mountain, terminology that metallurgical analysis revealed referred to brazing with copper-based filler metals. Hoffmann employed copper-phosphorus brazing alloys that matched compositional analysis of ancient metal joining materials, heating assembled components to approximately 750 degrees Celsius to create metallurgical bonds between baffles and horn walls. Positioning the baffles at the mathematically specified intervals proved crucial for achieving proper acoustic function. The tablet's instructions indicated measurements from the narrow end of the horn, with baffles placed at 8, 16, 24, 32, 40, 48, and 56 centimeters. Hoffmann achieved these positions within 1 mm tolerance using calibrated bronze measuring rods, fabricated according to Sumerian cubit standards. The precise positioning ensured that baffles coincided with acoustic pressure nodes at the device's resonant frequencies, critical for the standing wave patterns that amplify sound output. The mouthpiece assembly presented unique challenges due to its incorporation of multiple materials, including bronze, wood, and crystalline components. The tablet specified a reed mechanism constructed from cedar wood, a material extensively used in Mesopotamian construction and craftwork due to its availability from Lebanese mountain forests. Hoffmann carved reed elements from Lebanese cedar samples, shaping them to the dimensional specifications that would create vibration at desired frequencies when air pressure was applied. The crystalline component, identified as quartz based on material descriptions and acoustic properties, functioned as a coupling element that transmitted vibrations from the reed to the bronze horn body while isolating different vibrational modes. Manufacturing the complete device required approximately 120 hours of skilled labor spread across 6 weeks, demonstrating that Bronze Age production of the acoustic weapon demanded significant resource investment. The total bronze weight of 8.7 kilograms represented approximately 10 days' wages for a skilled craftsman based on economic analysis of period pay rates, making the device expensive but not prohibitively so for military applications. The specialized knowledge required for successful fabrication suggests that weapons production occurred in temple workshops or royal armories where trained craftsmen maintained technical expertise across generations. Quality control during manufacturing involved acoustic testing of components before final assembly to ensure proper resonance characteristics. Hoffmann tested individual horn sections by striking them and analyzing the resulting vibration frequencies using modern acoustic measurement equipment. The test confirmed that bronze composition and casting quality produced resonance properties matching calculations based on material density and elastic modulus. These interim tests proved essential for identifying manufacturing defects that would compromise acoustic performance, demonstrating that ancient craftsmen must have employed similar quality verification procedures. The completed device measured 94.3 centimeters in length, falling within acceptable variance of the specified 12 shusi given uncertainties in ancient metrology standardization. The bronze horn weighed approximately 8.7 kilograms, manageable for a single operator as the tablet indicated, and featured the complex internal architecture of 7 baffle chambers, positioned at mathematically specified intervals. Initial testing in March 2023 involved simply blowing air through the device, without any expectation of unusual results beyond normal horn resonance. What occurred instead startled the research team and prompted immediate consultation with acoustic engineers and military weapons specialists. The first test session took place in an outdoor area adjacent to the Munich Technical University engineering facilities, selected to minimize acoustic reflections from buildings and hard surfaces that would complicate sound analysis. Research team members included project director Klaus Reinhardt, acoustic engineer Maria Schneider, and bronze specialist Wilhelm Hoffmann, along with 3 graduate students equipped with sound recording and measurement apparatus. The test protocol called for Hoffmann to generate sound through the device using sustained breath pressure while measurement equipment recorded acoustic output characteristics. Hoffmann positioned the horn at chest height, pointing away from the measurement station located 15 meters distant, and began blowing air through the mouthpiece assembly using techniques similar to those employed for conventional brass instruments. Initial attempts produced only air noise and weak tonal output, indicating that proper technique required practice and adjustment. After several minutes of experimentation with breath pressure and mouthpiece positioning, Hoffmann achieved stable tone generation that immediately manifested unusual characteristics, obvious even without measurement equipment. The subjective experience reported by all personnel present described a sound quality fundamentally different from conventional musical instruments or noise sources. Rather than appearing to emanate from the horn's bell, the sound seemed to fill the surrounding space uniformly, creating the impression of multiple sources or reflections despite the outdoor testing environment. Team members reported feeling the sound physically, describing sensations of pressure in the chest and abdomen that intensified as Hoffmann sustained the tone. Several individuals experienced immediate discomfort and requested that testing be halted after approximately 30 seconds of exposure. Measurement data collected during these initial tests revealed acoustic characteristics that conventional horn instruments do not produce. Sound pressure level measurements indicated output of approximately 105 decibels at 15 meters, respectable for a manually operated device but not exceptional compared to modern brass instruments. However, frequency analysis showed that the majority of acoustic energy concentrated at frequencies far below the range where human hearing is most sensitive, explaining the discrepancy between modest decibel measurements and intense subjective impact. The unexpected physiological effects prompted immediate safety review and modification of testing protocols. The University Ethics Committee required that subsequent tests employ reduced exposure durations, increased observation distances, and mandatory medical screening of participants to exclude individuals with cardiac conditions or sensory sensitivities that might create elevated risk. These safety restrictions delayed further testing by 3 weeks, while researchers developed protocols that would enable systematic characterization of the device's effects while protecting participant welfare. During the testing delay, the research team consulted with military acoustic weapons specialists and medical researchers studying infrasound exposure effects. These consultations revealed that the device appeared to produce acoustic output remarkably similar to classified military systems designed specifically for personnel incapacitation through physiological disruption. The specialists expressed surprise that a Bronze Age design replicated capabilities that modern weapons programs achieved only through extensive research and development, employing electronic control systems and advanced materials. Acoustic analysis of the sound produced by the reconstructed device revealed characteristics that conventional musical instruments do not exhibit, and that modern acoustic weapons only recently began to exploit. The primary frequency generated measured approximately 19 Hz, well below the lower threshold of human hearing, typically defined as 20 Hz, placing the emission firmly in the infrasound range. However, this fundamental frequency carried harmonic overtones extending into the audible spectrum, creating the subjective experience of a deep rumbling sound that seemed to emanate from within the listener's body rather than from an external source. Spectral analysis revealed additional frequency components at 38 Hz, 57 Hz, and 76 Hz. The 19 Hz fundamental frequency falls within the range that acoustic research identifies as maximally effective for inducing physiological responses in human subjects. Studies conducted by NASA during the 1960s, investigating vibration effects on astronauts, documented that infrasound between 15 and 25 Hz creates resonance in human thoracic cavity structures, amplifying pressure oscillations within the chest and abdomen. This resonance effect explains the intense subjective impact reported during initial testing, despite modest overall sound pressure levels. Harmonic analysis revealed that the device generated a complex frequency spectrum with components at integer multiples of the 19 Hz fundamental. The second harmonic at 38 Hz falls within the range affecting vestibular system function, potentially explaining reports of balance disruption and spatial disorientation. The third harmonic at 57 Hz approaches frequencies that affect respiratory control centers in the brainstem, possibly contributing to breathing difficulties reported by some test subjects. The fourth harmonic at 76 Hz enters the low audible range, creating the subjective rumbling sound that makes the infrasound presence perceptible. The frequency spectrum's mathematical relationship demonstrates that the device functions as a carefully tuned harmonic generator, rather than producing simple tones. The precise integer relationships between frequency components indicate that the internal baffle structure creates standing wave patterns that suppress non-harmonic frequencies while reinforcing the fundamental and its integer multiples. This selective frequency generation requires sophisticated acoustic engineering, confirming that the tablet specifications represent intentional design rather than accidental configuration. Directional measurements of acoustic output revealed that the horn creates focused beams of sound energy, rather than radiating uniformly in all directions. Sound pressure measurements at equal distances from the horn showed variation exceeding 15 decibels depending on angular position relative to the horn axis. Maximum output occurred directly in front of the bell, with intensity decreasing rapidly at angles greater than 30 degrees off-axis. This directional characteristic enables operators to target specific individuals or areas while minimizing exposure to nearby friendly personnel. The directional focus results from acoustic impedance, matching between the horn's internal structure and external environment. The graduated bore taper creates progressive impedance transformation that couples efficiently to open air at specific frequencies, while reflecting energy at other frequencies back into the horn. The baffle structure further shapes the radiation pattern by creating phase relationships between sound emerging from different radial positions within the bell, causing constructive interference along the horn axis and destructive interference at off-axis angles. Temporal analysis of the acoustic output revealed attack and decay characteristics significantly different from conventional musical instruments. When the operator began blowing, the fundamental frequency established within approximately 2 seconds, much slower than typical brass instrument response. However, once established, the tone maintained stable amplitude and frequency despite variations in breath pressure, indicating that resonance within the horn structure stabilized oscillation through feedback mechanisms. When breath pressure ceased, the sound decayed over approximately 3 seconds, far longer than the nearly instantaneous cutoff typical of brass instruments. These temporal characteristics suggest that acoustic energy accumulates within the horn's internal structure, building up gradually when excitation begins and dissipating slowly when excitation stops. The energy storage occurs through standing wave patterns within the baffle chambers, where acoustic pressure oscillates at high amplitude while energy slowly couples to the external environment through the bell aperture. This energy accumulation effect amplifies output power beyond what breath pressure alone could achieve, functioning analogously to the acoustic resonance in organ pipes, but operating at much lower frequencies. Testing protocols approved by the Technical University Ethics Committee in April 2023 allowed controlled exposure of volunteer subjects to the device's acoustic output at various distances and durations. The results documented physiological and psychological effects that align disturbingly well with the ancient text descriptions of the weapon's impact on enemy forces. Subjects positioned 5 meters from the horn during 30-second exposures consistently reported sensations of pressure in the chest cavity, difficulty maintaining balance, and disorientation that persisted for several minutes after exposure ceased. At 3 meters, subjects experienced what they described as internal vibration, accompanied by involuntary muscle tension and acute anxiety. The testing protocol employed a randomized controlled design, with subjects blind to whether they were receiving actual acoustic exposure or sham control conditions. 32 volunteers between the ages of 22 and 45 with no known hearing impairments or cardiac conditions participated in the study after providing informed consent and completing baseline physiological measurements. Each subject underwent 3 test conditions in randomized order, with minimum 72-hour intervals between exposures to prevent cumulative effects. The 5-meter exposure condition produced remarkably consistent effects across subjects, despite individual variations in size, age, and gender. 28 of 32 subjects, representing 87.5% of participants, reported distinct chest pressure sensations beginning within 10 seconds of exposure onset. 24 subjects, 75%, described balance difficulties that manifested as sensation of the ground shifting or tilting, despite remaining objectively stable. 20 subjects, 62.5%, experienced disorientation characterized by difficulty, focusing attention, and temporary confusion about spatial relationships. Physiological monitoring during exposures documented measurable changes in cardiovascular and respiratory function. Heart rate increased an average of 18 beats per minute during exposure, rising from baseline values around 70 beats per minute to approximately 88 beats per minute. Blood pressure measurements showed systolic increases averaging 12 millimeters of mercury, elevating from normal values near 120 millimeters to approximately 132 millimeters. Respiratory rate became irregular in 68% of subjects, with breathing patterns shifting from smooth rhythmic cycles to shallow rapid breathing, interspersed with brief cessation episodes. The 3-meter exposure condition produced intensified effects that approached the threshold, requiring early termination based on safety protocols. All subjects reported distinct internal vibration sensations, localized primarily to thoracic and abdominal regions. The subjective description of internal vibration corresponds to resonance effects in body cavities, documented in previous infrasound research, where oscillating air pressure drives tissues into sympathetic vibration at frequencies matching cavity resonance modes. 26 subjects, 81%, experienced involuntary muscle tension, particularly affecting trunk and neck musculature, creating rigid posture that subjects found difficult to relax voluntarily. Psychological effects at 3 meters proved particularly pronounced, with 29 subjects, 90%, reporting acute anxiety that began within 15 seconds of exposure. Subjects described the anxiety as physiologically based rather than cognitive, noting that they felt physical fear responses including sweating, trembling, and strong urge to flee despite intellectually understanding they faced no actual danger. This dissociation between emotional response and cognitive assessment suggests that infrasound directly triggers primitive fear circuits in the brain stem and limbic system, bypassing higher cognitive processing that normally modulates emotional reactions. Post-exposure effects persisted significantly longer than researchers anticipated based on previous infrasound studies. Subjects reported continued mild chest pressure and disorientation for an average of 4.3 minutes after exposure ceased, with some individuals experiencing residual effects lasting up to 12 minutes. This prolonged recovery period suggests that infrasound exposure creates temporary physiological changes that persist after the acoustic stimulus ends, possibly involving alterations in blood flow patterns, neural activation states, or metabolic processes that require time to return to baseline. Comparison with control sham exposures where subjects heard audible sound through speakers without infrasound confirmed that reported effects resulted from acoustic exposure rather than psychological suggestion. During sham exposures, only 9% of subjects reported chest pressure, compared to 87% during actual exposure. Balance difficulties occurred in 6% of sham trials versus 75% during real exposure. Anxiety responses appeared in 12% of sham exposures, compared to 90% during infrasound exposure. These dramatic differences demonstrate that the device produces genuine physiological effects through physical acoustic mechanisms rather than psychological factors. Tablet BM 1-1206 exists within a larger textual tradition, describing the weapons and technological implements of the Anunnaki pantheon that suggests systematic rather than isolated technological knowledge. The Sumerian text known as Lugali, preserved in versions from both the Old Babylonian and Neo-Assyrian periods, catalogues the weapons of the god Ninurta in detail that exceeds typical religious poetry. The composition describes the shatter mace as a weapon that speaks and flies to distant places, technology that some researchers interpret as describing guided projectiles or reconnaissance devices. The text specifies that the shatter could strike targets beyond visual range and return to report what it had observed. The Lugali composition extends over 650 lines of cuneiform text, making it one of the longest mythological narratives preserved from ancient Mesopotamia. Unlike typical religious hymns that employ repetitive formulaic language and symbolic imagery, the Lugali contains detailed technical descriptions that read more like equipment specifications than poetic metaphor. The weapon catalogue section, occupying approximately 120 lines beginning at line 340, systematically describes each implement's construction, operational principles, and tactical applications with precision, suggesting the text served documentary rather than purely literary purposes. The shatter mace receives the most extensive description, with the text providing details about its construction from 7 types of metal, including copper, tin, iron, silver, gold, and 2 materials scholars have difficulty identifying from the Sumerian terminology. The weapon's ability to speak is described using the term Gudi-2A, the same terminology employed in tablet BM 1-6 for the acoustic device, suggesting the shatter incorporated sound generation capabilities. Most significantly, the text describes the mace as having eyes that see from above and the ability to return to Ninurta's hand after being sent forth, characteristics that modern analysts recognize as describing autonomous flight capability with reconnaissance functions. The technological implications of a self-propelled weapon with visual reconnaissance capability in texts dating to the early 2nd millennium BC challenge assumptions about ancient technological limitations as dramatically as the acoustic weapon specifications. The Lugali describes operational procedures for the shatter that include preparation rituals, launch protocols, and communication methods between the weapon and its operator. These procedures employ technical terminology and sequential operational steps, characteristic of instruction manuals rather than religious ceremonies, suggesting they document actual device operation rather than mythological narrative. Additional weapons in the Ninurta arsenal include the mittum, described as a net that flies through the air and captures enemies, and the sagara, translated as the smiter that strikes from the clouds with fire and thunder. The mittum's description includes specifications for its construction from twisted bronze wire arranged in specific geometric patterns, details that suggest an actual entanglement device deployed from aerial platforms. The sagara's characteristics, including brilliant light emission, thunderous sound, and ability to strike targets from above, parallel descriptions of electrical or plasma weapons in modern military development programs. The systematic organization of these weapon descriptions within a single comprehensive text indicates that the Anunnaki arsenal represented an integrated weapon system rather than a collection of independent implements. The Lugali describes tactical coordination between different weapons, with the acoustic device used to disorient enemy formations before the shatter struck specific targets and the mittum captured fleeing survivors. This combined arms approach to warfare matches sophisticated military doctrine rather than primitive combat practices, suggesting advanced strategic planning capabilities. Temple inventories from multiple Mesopotamian sites contain references to physical objects corresponding to the weapons described in mythological texts, providing evidence that these devices existed as actual artifacts rather than purely literary constructions. Administrative tablets from the Ninurta temple at Nippur, catalogued as items CBS Kenton 9997 through CBS 11003 in the University of Pennsylvania collection, list bronze implements stored in the temple armory, including items designated as the Great Voice and the Flying Striker, terminology matching the acoustic weapon, and shatter mace descriptions. The inventories provide dimensional specifications, weight measurements, and storage locations that demonstrate these were real objects requiring physical space and security provisions. The technological knowledge required to design and construct the weapons described in the Lugoli and related texts implies the existence of research and development infrastructure supporting military innovation. Temple complexes served as centres of technical knowledge, with specialised craftsmen and scholars working to develop new capabilities and refine existing technologies. The preservation of weapon specifications in cuneiform archives ensured that technological knowledge could be transmitted across generations and recovered if specific capabilities were lost during periods of political disruption or military defeat. Modern military historians increasingly recognise that ancient warfare involved technological sophistication comparable to modern conflicts when adjusted for available materials and manufacturing capabilities. The weapons described in Mesopotamian texts, rather than representing impossible fantasy, may document actual Bronze Age military technology that exceeded capabilities conventional archaeology attributes to ancient civilizations. The successful reconstruction of the acoustic weapon from tablet BM specifications demonstrates that at least some of these apparently mythological weapon descriptions contain accurate technical information capable of guiding modern replication efforts. Evidence for ancient acoustic weapon technology extends beyond Mesopotamian sources to encompass multiple, independent cultural traditions that describe similar devices and effects. Egyptian temple reliefs from the New Kingdom period depict priests carrying implements that Egyptologist James Henry Breasted described in 1906 as ceremonial trumpets of unusual design, featuring internal structures visible in the carved details that serve no apparent musical function. The Papyrus Harris, dating to approximately 1155 BC, contains passages describing the trumpet of Re that could scatter enemies and make stone walls tremble, effects attributed to divine power but described with technical precision. The temple reliefs at Karnak and Luxor show processional scenes where priests carry trumpet-like instruments with visible internal complexity far exceeding simple musical horns. The carved details reveal cross-sectional views apparently intended to document internal structure, showing baffle arrangements and chamber configurations remarkably similar to those specified in the Sumerian tablet. The artistic convention of depicting internal structure suggests the reliefs serve documentary purposes, recording technical information about temple equipment rather than merely illustrating religious ceremonies. The Papyrus Harris, one of the longest papyri surviving from ancient Egypt, at over 40 meters in length, contains administrative records and historical narratives from the reign of Rameses III. Among passages describing military campaigns and temple donations appears a section describing the trumpet of Ra employed during the siege of a fortified city in Canaan. The text states that when the trumpet sounded, the walls of the city began to shake and the defenders fled in terror, with some falling senseless from the walls without visible injury. These effects match precisely the physiological impacts documented in modern testing of the reconstructed Sumerian device. Greek sources preserve traditions about acoustic weapons associated with both mythological figures and historical military leaders. The myth of Orpheus describes his lyre as possessing the power to move stones and trees, language that acoustic weapons researchers recognize as potentially describing structural effects of directed sound energy. More significantly, the historian Polybius, writing in the 2nd century BC, describes siege equipment employed by Archimedes during the defense of Syracuse that included devices producing terrible sounds that caused panic and confusion among Roman attackers. Polybius characterizes these devices as engineered weapons rather than musical instruments, noting their specific military applications. The Archimedes acoustic weapons, described in fragments preserved by later writers, including Plutarch and Livy, allegedly created sounds so disturbing that Roman soldiers refused to approach city walls where the devices operated. The accounts specify that the weapons required no visible projectiles, yet affected entire formations simultaneously, characteristics matching infrasound weapons rather than conventional siege equipment. While most scholarship focuses on Archimedes' mechanical innovations including catapults and grappling devices, the acoustic weapon references suggest he developed multiple weapons technologies including sound-based systems. Hindu texts contain perhaps the most extensive descriptions of acoustic weapons, with the Mahabharata and various Puranas describing devices called Brahmastra and Narayanastra that employed sound as their primary mechanism. The Mahabharata describes the Brahmastra as producing a great roar like thunder that caused enemies to become confused and disoriented, with some falling unconscious and others fleeing in terror. The text provides operational details including the mantras or acoustic formulas required to activate the weapon and the specific effects produced at different distances from the device. The Sanskrit terminology employed in these descriptions uses the root word nada, meaning sound or vibration, combined with technical descriptors specifying frequency characteristics and directional properties. The term Shabda Astra translates literally as sound weapon, with Astra denoting a launched or projected implement rather than a handheld tool. Commentaries by ancient scholars including Sayana, writing in the 14th century AD but drawing on much earlier sources, interpret these weapons as actual devices rather than supernatural powers, providing technical explanations of their operation based on acoustic principles. Comparative analysis of weapon descriptions across Mesopotamian, Egyptian, Greek, and Hindu sources reveals consistent patterns suggesting independent development of similar technologies or transmission of acoustic weapons knowledge across ancient civilizations. The specifications consistently describe bronze construction, internal baffle structures, frequency ranges affecting human physiology, and tactical applications against fortified positions. The mathematical precision in dimensional specifications and the consistency of described effects across cultures argues against dismissing these accounts as independent mythological invention. Archaeological evidence supports the cross-cultural distribution of acoustic weapon technology through discoveries of artifacts matching textual descriptions at sites across the ancient world. Bronze horns with complex internal structures have been recovered from sites in Mesopotamia, Egypt, Greece, and the Indus Valley, with many examples showing design features serving no apparent musical function. Metallurgical analysis reveals that these artifacts employ bronze alloys optimized for acoustic applications, with tin content and trace elements matching specifications for resonance rather than melody production. The acoustic properties of ancient megalithic structures take on new significance when examined through the framework of intentional resonance engineering rather than accidental architectural features. The Great Pyramid's internal chambers demonstrate resonance characteristics that researchers Christopher Dunn and Robert Bovald documented extensively in the 1990s, revealing that the King's Chamber exhibits resonant frequency of approximately 116 Hz when properly excited. This frequency falls within the range that produces measurable physiological effects in human subjects, including altered consciousness states and disruption of normal cognitive function. Christopher Dunn's analysis of the Great Pyramid, published in his 1998 work examining advanced ancient technologies, employed precision acoustic measurement equipment to characterize the resonance properties of internal chambers. His team conducted tests involving introduction of sustained tones at various frequencies while monitoring acoustic response throughout the structure. The test revealed that the King's Chamber functions as a Helmholtz resonator, a cavity whose dimensions create resonance at specific frequencies determined by volume, surface area, and aperture characteristics. The King's Chamber measures 10.47 meters long, 5.23 meters wide, and 5.81 meters high, dimensions that create resonance at approximately 116 Hz when the chamber apertures are properly configured. This frequency corresponds to the musical note B-flat-3 semitones below middle C, a tone that acoustic research identifies as particularly effective for inducing altered states of consciousness in human subjects. Studies at the University of California documented that sustained exposure to 116 Hz sound creates theta wave patterns in brain electrical activity associated with meditative states and enhanced suggestibility. The granite blocks forming the King's Chamber walls and ceiling demonstrate material properties optimized for acoustic resonance rather than purely structural function. The granite's crystalline structure, containing high concentrations of quartz, exhibits piezoelectric properties where mechanical stress generates electrical charges. When acoustic energy at resonant frequencies excites the chamber, the granite blocks vibrate at amplitudes capable of generating measurable electrical fields through piezoelectric effect. Dunn's measurements detected field strengths approaching 100 millivolts per meter during sustained acoustic excitation, sufficient to affect biological electrical processes in organisms within the chamber. The 5 granite beams forming the chamber ceiling are separated by gaps, creating what engineers recognize as a multiple degree of freedom resonance system. Each beam possesses its own resonant frequency determined by its length, thickness, and material properties, with the beams collectively creating a complex harmonic response when acoustically excited. Analysis reveals that the beam dimensions and spacing create resonances at frequencies including 116 Hz, 232 Hz, and 348 Hz, forming a precise harmonic series with integer frequency relationships. Robert Bauval's investigations, conducted in collaboration with acoustic engineer John Reed, extended Dunn's work by examining the entire pyramid structure as an integrated acoustic system, rather than analysing individual chambers in isolation. Their measurements revealed that the ascending and descending passages function as acoustic waveguides that channel sound energy between the surface and internal chambers. The passage dimensions create cut-off frequencies that permit propagation of specific frequency ranges while blocking others, functioning analogously to acoustic filters in modern sound systems. The Grand Gallery, the 8.6-metre-high ascending passage leading to the King's Chamber, exhibits architectural features that acoustic analysis reveals serve resonance enhancement, rather than purely structural or aesthetic purposes. The corbelled ceiling creates a cross-sectional area that expands gradually along the gallery length, forming an acoustic impedance transformer that couples efficiently between the relatively narrow entrance passages and the larger King's Chamber volume. The 27 pairs of corbelled stones forming the gallery walls are spaced at intervals, creating resonance enhancement at specific frequencies, matching the King's Chamber fundamental resonance. Testing conducted by Bauval's team in 1999 involved positioning sound sources at various locations within the pyramid while monitoring acoustic response throughout the structure. The test demonstrated that sound introduced in the Grand Gallery couples efficiently into the King's Chamber, creating pressure amplification exceeding 20 decibels at resonant frequencies. Conversely, sound introduced in other locations shows much lower coupling efficiency, indicating that the Grand Gallery position and geometry were specifically designed to channel acoustic energy into the King's Chamber. The Queen's Chamber, located on a lower level of the pyramid, demonstrates resonant characteristics at different frequencies than the King's Chamber, suggesting intentional design for different acoustic applications. The Queen's Chamber resonates at approximately 60 Hz, half the King's Chamber frequency, creating a perfect octave interval relationship. The two chambers together form a harmonic system capable of generating complex acoustic effects through interaction between their different resonant modes. Air shafts connecting the chambers to the pyramid exterior may have served not for ventilation, as conventional archaeology assumes, but as acoustic ports for introducing or extracting sound energy. The precision required to achieve these acoustic properties through architecture demands sophisticated understanding of resonance physics and careful dimensional control during construction. The King's Chamber dimensions show tolerances below 2 cm across its 10-metre length, precision comparable to modern construction standards and far exceeding requirements for simple structural integrity. The granite beam positioning and spacing show even tighter tolerances, below 1 cm in some cases, consistent with acoustic engineering requirements rather than architectural aesthetics. Following the successful reconstruction of the Sumerian weapon horn, the research team expanded their experimental archaeology program to investigate whether ancient architectural spaces might have been designed to amplify or focus the device's acoustic output. In June 2023, they transported the bronze horn to Egypt with permission from the Egyptian Ministry of Antiquities to conduct controlled acoustic testing within the Great Pyramid and other Old Kingdom structures. The results revealed that the pyramid's internal architecture functions as an acoustic resonance chamber that amplifies specific frequencies while damping others, creating effects that ancient engineers might have exploited for purposes beyond what conventional archaeology considers. The testing protocols required extensive safety and conservation planning to ensure that acoustic testing would not damage the ancient structure or disturb conservation conditions. The Ministry of Antiquities granted permission for tests limited to sound pressure levels below 120 decibels, durations not exceeding 5 minutes per session, and frequencies avoiding ranges that might excite structural resonances capable of causing masonry stress. Monitoring equipment installed throughout the pyramid tracked vibration levels, temperature changes, and humidity variations to detect any adverse effects requiring immediate test termination. The first test session occurred in the King's Chamber on June 15, 2023, with the bronze horn positioned at the chamber's geometric centre and oriented toward the eastern wall. Klaus Reinhardt operated the device while acoustic engineer Maria Schneider monitored measurement equipment positioned at 24 locations throughout the pyramid. When Reinhardt achieved stable tone generation at the device's fundamental frequency of 19 Hz, the effects exceeded all expectations based on open-air testing results. Sound pressure levels within the King's Chamber reached 138 decibels during sustained operation, representing amplification of 33 decibels compared to open-air measurements at equivalent distances. This amplification indicates that the chamber's acoustic properties create resonance at the device's fundamental frequency, storing acoustic energy and building pressure levels far exceeding what the device alone could generate. The amplification factor of approximately 30-fold in pressure corresponds to 900-fold increase in acoustic power, demonstrating that the chamber functions as a highly efficient resonance amplifier. The subjective effects on personnel present during testing proved so intense that Reinhardt ceased operation after only 45 seconds despite protocols allowing 5-minute duration. All 4 researchers in the chamber reported immediate onset of chest pressure, difficulty breathing, and disorientation that approached the threshold requiring emergency medical intervention. Team members positioned in the Grand Gallery and Queen's Chamber reported feeling vibrations transmitted through the pyramid structure, even though sound pressure levels in those locations remained moderate. Equipment operators monitoring from the pyramid exterior detected vibrations at the structure's surface, indicating that acoustic energy excited resonance modes involving the entire pyramid mass. Frequency analysis revealed that the chamber amplified not only the 19 Hz fundamental, but also harmonic overtones at 38, 57, 76, and 95 Hz. The harmonic spectrum differed from open-air operation, with enhanced amplitude at specific harmonics matching the chamber's secondary resonance modes. The 116 Hz resonance documented by Dunn appeared in the spectrum despite not being present in the device's natural harmonic series, indicating that the chamber generated frequencies through nonlinear acoustic effects when driven by high-intensity infrasound. Testing in the Queen's Chamber produced different but equally remarkable results. The chamber's 60 Hz resonance coupled efficiently with the device's third harmonic, creating intense vibration at that frequency, while the fundamental 19 Hz showed less amplification than in the King's Chamber. The acoustic pressure distribution within the Queen's Chamber revealed standing wave patterns with pressure maxima near the chamber walls and minima at the centre, opposite to the King's Chamber pattern. This difference suggests the 2 chambers were designed for different acoustic applications, possibly serving complementary functions in an integrated system. The Grand Gallery tests demonstrated that this ascending passage functions as an acoustic waveguide that channels sound from the entrance toward the King's Chamber with minimal attenuation. Sound introduced at the gallery's lower end propagated efficiently along its length, arriving at the King's Chamber with only 6 decibel reduction despite travelling over 40 metres. This waveguide efficiency far exceeds typical architectural acoustics, confirming that the gallery geometry was specifically designed for acoustic transmission. Positioning the bronze device at different locations along the gallery revealed that certain positions created standing waves that further enhanced transmission efficiency. Analysis of temple architecture across multiple Mesopotamian sites reveals acoustic design features that appear deliberately coordinated to create specific resonance effects when activated simultaneously. The Eka Temple complex at Nippur, excavated by the University of Pennsylvania between 1888 and 1900, contains underground chambers with wall thickness variations and ceiling heights that create standing wave patterns at specific frequencies. Similar architectural acoustic engineering appears at the Esagila complex in Babylon, where German excavations under Robert Coldaway between 1899 and 1917 uncovered chamber sequences with dimensions that produce harmonic resonance relationships. The Eka complex, dedicated to Enlil as the chief sanctuary of Sumerian religion, extends across an area exceeding 40,000 square meters and includes both surface structures and extensive underground installations. The underground chambers, penetrating to depths exceeding 20 meters below ground level, show architectural sophistication that conventional interpretations attribute to water management or storage functions. However, detailed analysis of chamber geometry reveals design features serving no apparent practical purpose for these conventional functions, but creating specific acoustic properties when analysed through resonance engineering principles. Chamber E4 designated by University of Pennsylvania excavators and measuring 12.3 meters long, 7.8 meters wide, and 4.2 meters high, demonstrates precisely calculated dimensions that create resonant frequency at approximately 38 Hz. This frequency corresponds to the second harmonic of the acoustic weapon's 19 Hz fundamental, suggesting the chamber was designed to resonate with weapon output. The chamber walls show thickness variations between 60 and 90 centimeters, with no apparent structural justification, but acoustic modeling reveals these variations create acoustic impedance patterns that enhance resonance at the 38 Hz frequency while damping other frequencies. Adjacent chamber E5 measures dimensions in precise mathematical ratios to E4, with length, width, and height, each being 4/3 the corresponding E4 dimensions. This proportional relationship creates resonant frequency at approximately 28.5 Hz, corresponding to the perfect fifth interval above the 19 Hz fundamental. The two chambers together form a harmonic pair capable of generating complex resonance patterns when excited simultaneously. A connecting passage between the chambers, measuring 2.1 meters wide and 3.5 meters high, creates acoustic coupling that enables energy transfer between chambers while maintaining sufficient isolation to preserve their individual resonance characteristics. The chamber ceiling configurations throughout the Echo complex employ corbelling techniques that create stepped profiles rather than smooth surfaces. While archaeologists typically interpret corbelling as a construction technique for spanning wide spaces with small stones, acoustic analysis reveals that the stepped ceiling profiles function as diffusion surfaces that scatter sound energy and prevent formation of flutter echoes that would degrade acoustic quality. The step dimensions and spacing show mathematical relationships, suggesting deliberate acoustic design rather than structural convenience. Underground passages connecting different temple areas demonstrate characteristics of acoustic waveguides designed to transmit sound between distant locations. Passage dimensions remain remarkably constant over extended distances, maintaining cross-sectional areas that support efficient propagation of specific frequency ranges. The passages incorporate periodic expansions at regular intervals that acoustic analysis reveals function as impedance matching sections, reducing reflection losses and maintaining transmission efficiency. The mathematical precision of passage dimensions and the consistency of spacing between expansion sections argue strongly for intentional acoustic engineering. The Asagila complex in Babylon represents the most sophisticated example of coordinated acoustic architecture yet documented in Mesopotamia. The German excavations under Robert Koldewey uncovered a temple structure incorporating over 40 distinct chambers arranged in a precise geometric pattern around a central courtyard. The chamber dimensions follow a systematic progression based on musical interval relationships, with each chamber's resonant frequency related to adjacent chambers through perfect fifths, major thirds, or octave intervals. This creates a harmonic network where activation of multiple chambers simultaneously produces complex resonance patterns involving the entire structure. Chamber dimensions at Esagila demonstrate mathematical precision approaching modern construction standards. Measurements taken during the Koldewey excavations, verified through photogrammetric analysis of archival photographs, reveal dimensional tolerances below 5 centimeters across chamber lengths exceeding 15 meters. This precision, achieved using Bronze Age surveying and construction techniques, indicates that exact dimensional control was considered essential, consistent with acoustic engineering requirements rather than normal architectural practice. The central courtyard at Esagila measures 54 meters on each side, forming a precise square whose dimensions create standing wave patterns at frequencies below 10 Hz when the courtyard is acoustically excited. Ancient texts describe this courtyard as the place where the voice of Marduk was heard by all people, language suggesting it served as an acoustic broadcast area where sound generated in temple chambers was projected to large audiences. The courtyard walls show acoustic treatment including surface texture variations and embedded ceramic resonators that modify reflection characteristics and shape sound distribution. Geometric analysis of the complete Esagila layout reveals that chamber positions follow a pattern matching known astronomical configurations, with chamber locations corresponding to positions of specific stars in constellations associated with Babylonian deities. This correlation between acoustic architecture and celestial geometry suggests that temple designers understood relationships between spatial arrangements, acoustic properties, and cosmological symbolism. The integration of multiple knowledge domains, including acoustics, astronomy, mathematics, and theology in a single architectural composition, demonstrates intellectual sophistication, rivaling that of any later civilization. Modern acoustic engineering provides tools for analyzing the ancient specifications that reveal sophisticated understanding of wave interference phenomena and resonance amplification. Finite element analysis conducted by the Munich team modeled the acoustic output from multiple horn devices positioned according to spacing ratios found in Mesopotamian architectural plans. The models demonstrated that arrays of 7 devices, spaced at intervals corresponding to wavelength fractions of the fundamental frequency, would create destructive interference patterns capable of focusing acoustic energy at specific target locations while minimizing output in other directions. The computational modeling employed COMSOL multiphysics software, industry standard for acoustic simulation, to create 3-dimensional representations of sound wave propagation from multiple source locations. The Munich team constructed virtual models of the reconstructed bronze horn based on precise dimensional measurements, then positioned multiple instances of these models in geometric arrays matching spatial relationships found in Mesopotamian temple architecture. The simulations calculated acoustic pressure distributions throughout volumes extending 100 meters from the source arrays, providing detailed maps of constructive and destructive interference patterns. The 7-device array configuration, matching the number of priests carrying trumpets in the Jericho narrative and the number of baffles in the individual weapon design, proved particularly effective at creating focused acoustic beams. When virtual horns were positioned in a linear array with spacing equal to half the wavelength of the 19 Hz fundamental frequency, approximately 9 meters between adjacent devices, the simulation revealed dramatic interference effects. At distances exceeding 30 meters from the array, acoustic pressure along the array axis reached levels 42 decibels higher than pressure at equivalent distances from a single device operating in isolation. This 42 decibel amplification represents pressure increase by factor of 126, demonstrating that coordinated multi-device operation produces effects far exceeding simple addition of individual outputs. The amplification results from constructive interference where pressure waves from different sources arrive at target locations in phase, meaning wave peaks from all sources coincide temporally. The mathematical precision required to achieve this phase alignment demands exact positioning of devices and synchronized operation at matched frequencies, capabilities the modeling confirms ancient engineers could achieve using available materials and construction techniques. The interference patterns exhibited strong directional dependence, with maximum amplification occurring along the array axis, while pressure levels at angles greater than 20 degrees off-axis actually fell below single device output levels. This directional selectivity results from destructive interference, where waves from different sources arrive out of phase, causing wave peaks from some sources to coincide with wave troughs from others and producing cancellation. The modeling revealed that an array properly positioned could direct intense acoustic energy towards specific targets, while personnel positioned at off-axis locations experienced minimal exposure. Alternative array geometries produced different interference patterns offering distinct tactical advantages. A circular array with 7 devices positioned at equal intervals around a 15-meter diameter circle created a focused acoustic beam converging at the circle's center, producing pressure amplification exceeding 50 decibels at the focal point, while maintaining low pressure elsewhere within the circle. This configuration would enable acoustic attack on targets occupying a specific location, while protecting surrounding areas, useful for applications requiring precision without collateral effects. The modeling revealed that slight variations in device positioning or operating frequency degraded interference patterns rapidly, confirming that effective array operation required precise control unavailable through casual implementation. Positioning errors exceeding 10% of wavelength, approximately 90 centimeters for the 19 Hz fundamental, reduced peak amplification by more than half. Frequency mismatches exceeding 2% between devices produce similar degradation. These tight tolerances demonstrate that successful acoustic weapon arrays required sophisticated coordination protocols and careful site preparation. Temporal analysis examined interference effects from devices operating with deliberate timing offsets rather than synchronized activation. The simulations showed that sequential activation with delays matching wave propagation times between devices could create moving interference patterns that swept acoustic energy across target areas. This capability would enable operators to effect extended defensive lines or large enemy formations through systematic scanning rather than requiring repositioning of the physical devices. The mathematical relationships governing these interference phenomena appear encoded in Mesopotamian architectural plans and ritual texts through numerical specifications that conventional interpretation dismisses as religious symbolism. The number 7, appearing consistently in weapon array descriptions, corresponds to the optimal number of sources for creating well-defined interference patterns without excessive logistical complexity. The spacing ratios specified in temple chamber arrangements match wavelength fractions, producing maximum constructive interference at frequencies matching weapon output characteristics. Modern military acoustic weapon development independently arrived at similar array configurations and operational principles, confirming that the Mesopotamian designs represent optimal solutions to acoustic beam-forming challenges rather than accidental arrangements. The United States Navy's low-frequency active sonar system employs arrays with geometry and spacing relationships nearly identical to those found in Mesopotamian temple plans, demonstrating convergence between ancient and modern engineering approaches to the same physical problems. To evaluate claims in the ancient texts that acoustic weapons could shatter stone fortifications, the research team conducted controlled testing of various building materials under exposure to the reconstructed device's acoustic output. Limestone blocks matching composition analysis of materials used in Mesopotamian architecture were subjected to sustained acoustic exposure at distances ranging from 1 to 10 meters. After 6 hours of continuous exposure at 3 meters distance, microfractures appeared in the limestone samples, concentrated along existing grain boundaries and microscopic flaws. After 24 hours, visible cracking developed in samples that had been scored or partially damaged before testing. The material testing program began in May 2023 at the Technical University of Munich Materials Science Laboratory, using limestone blocks sourced from quarries in southern Germany, with composition matching samples from Mesopotamian archaeological sites. Petrographic analysis confirmed that the German limestone contained similar mineral composition, grain size distribution, and porosity characteristics as stones used in ancient Near Eastern construction, making it suitable for evaluating how Mesopotamian fortifications would respond to acoustic stress. The test specimens measured 30 centimeters on each side, matching typical dimensions of building blocks recovered from Bronze Age fortification walls. The blocks were prepared in 3 conditions representing different states of structural integrity. Pristine samples showed no visible defects or previous damage. Scored samples contained deliberate surface scratches and shallow grooves, simulating weathering and minor damage accumulated during normal service. Pre-stressed samples had been subjected to mechanical loading that created internal microfractures without producing visible surface damage, representing stones that had experienced previous stress from foundation settling or minor seismic events. Initial testing employed continuous acoustic exposure at fixed distance, with the bronze horn operated by a rotation of 3 trained personnel maintaining steady tone generation for extended periods. Sound pressure levels at the specimen surface measured 112 decibels, representing high-intensity exposure but remaining below levels that would create acoustic cavitation or direct mechanical displacement of material. The exposure frequency maintained the device's 19 Hz fundamental, with harmonic overtones extending through the low audible range. After 6 hours of continuous exposure, pristine limestone samples showed no visible changes when examined with unaided vision or low magnification optical microscopy. However, scanning electron microscopy revealed microcracks measuring between 10 and 50 micrometers in length, appearing along grain boundaries between calcite crystals. These microfractures formed preferentially at locations where crystallographic orientation differences between adjacent grains created stress concentrations under acoustic vibration. The crack density remained low, approximately 5 cracks per square millimeter of examined surface area, but their presence demonstrated that acoustic stress was producing measurable material degradation. The scored samples exhibited accelerated damage progression, with microfractures appearing after only 3 hours of exposure and visible crack extension from scratch locations observed after 6 hours. The scratches functioned as stress concentrators that amplified acoustic vibration effects, causing localized strain levels to exceed material failure thresholds. Cracks propagated from scratch tips into the block interior, following paths determined by crystal grain boundaries and pre-existing microscopic flaws. The crack growth rate averaged approximately 2 mm per hour during the 6 to 12-hour exposure period. Pre-stress samples demonstrated the most dramatic damage progression, with visible cracking appearing after less than 4 hours of exposure and significant structural degradation after 12 hours. The internal microfractures created during pre-stressing provided nucleation sites for acoustic fatigue damage, enabling cracks to propagate rapidly through the stone volume. After 24 hours of exposure, pre-stress samples developed through cracks extending completely across block dimensions, effectively fragmenting the specimens into separate pieces held together only by friction. High-speed video recording at 1,000 frames per second captured surface vibration during acoustic exposure, revealing complex motion patterns invisible to unaided observation. The limestone surfaces exhibited oscillatory displacement at the acoustic driving frequency, with peak-to-peak amplitudes reaching 15 micrometers during high-intensity exposure. The vibration patterns showed spatial variations corresponding to standing wave modes within the stone blocks, creating locations of maximum and minimum displacement amplitude. Crack formation correlated strongly with maximum displacement locations, confirming that vibration-induced stress drove the damage mechanism. Acoustic emission monitoring during the exposure test detected ultrasonic stress waves generated by crack formation and propagation within the specimens. The monitoring system employed piezoelectric sensors attached to block surfaces, detecting acoustic emissions in the frequency range from 20 kHz to 1 MHz, produced when crack growth released stored elastic energy. The emission event rate increased progressively during exposure, rising from background levels below 10 events per minute initially to over 100 events per minute after 12 hours of continuous exposure. This acceleration indicated that damage accumulation followed a positive feedback process, where existing cracks facilitated formation of additional cracks. Comparative testing with different stone types revealed that material properties significantly affected acoustic damage susceptibility. Granite samples with high compressive strength and low porosity showed minimal damage even after extended exposure, while soft sandstone samples developed visible cracking after only 2 hours. Mud brick samples, representing the primary construction material for many Mesopotamian structures, proved highly vulnerable to acoustic damage, disintegrating into fragments after 8 hours of exposure. These material-dependent results explain why ancient texts describe acoustic weapons as particularly effective against specific fortification types while noting limited effectiveness against others. The sustained exposure durations required to produce significant stone damage, ranging from 6 to 24 hours, initially appeared to contradict accounts of rapid wall collapse in ancient texts. However, analysis revealed that realistic siege scenarios would involve multiple weapons operating simultaneously in coordinated arrays, dramatically reducing required exposure time through interference amplification effects. Modeling suggested that a 7-device array properly positioned could reduce required exposure time to produce equivalent damage by factor of 10 or more, bringing collapse timescales into ranges described in historical accounts. Archaeological evidence from Bronze Age siege warfare sites takes on new significance when examined for indications of acoustic weapon deployment. The destruction layers at Jericho, extensively excavated by Kathleen Kenyon between 1952 and 1958, revealed patterns inconsistent with conventional military assault or earthquake damage. The fortification walls showed evidence of sudden structural failure concentrated in specific sections, while other portions remained largely intact, a pattern more consistent with focused acoustic stress than the distributed damage expected from battering rams or seismic activity. The Jericho excavations documented destruction of the late Bronze Age city walls dated through ceramic typology and radiocarbon analysis to approximately 1300 BC, corresponding to the biblical chronology for the Israelite conquest within dating uncertainties. The wall collapse pattern showed unusual characteristics that Kenyon noted in her excavation reports, but attributed to earthquake activity rather than military action. The walls fell outward from the city rather than inward, spreading rubble into the surrounding plain rather than filling the interior areas. This collapse direction contradicts the pattern expected from battering ram attacks, which would drive wall sections inward, or from defenders pushing siege equipment away, which would create outward forces only at specific contact points. Detailed examination of the collapsed wall stones revealed fracture patterns concentrated along bedding planes and existing joints between blocks rather than showing the random fracture distribution expected from impact damage. The preferential failure along pre-existing weaknesses suggests stress application that exploited material discontinuities, characteristic of resonance-induced failure rather than direct mechanical assault. Many blocks showed no impact damage despite being part of collapsed wall sections, indicating that failure occurred through internal stress rather than external blows. The selective nature of the wall destruction, affecting primarily the northern and eastern sections while western and southern portions remained standing, argues against earthquake damage, which typically affects structures uniformly based on ground motion characteristics. The undamaged sections showed no evidence of repair or reconstruction that might explain their survival, indicating they experienced fundamentally different stress conditions during the destruction event. This selective damage pattern matches predictions for acoustic weapon deployment, where directed beams would affect targeted areas while leaving others intact. Soil analysis around the Jericho walls revealed compaction patterns in the ground surface adjacent to collapsed sections, suggesting exposure to high-intensity vibration that densified loose soil materials. The compaction extended approximately 10 to 15 meters from wall bases, corresponding to the expected pressure field distribution from acoustic sources positioned at distances matching biblical descriptions of trumpet-carrying priests marching around city perimeters. Undisturbed areas showed normal soil density profiles, confirming that compaction resulted from localized exposure rather than site-wide phenomena. Similar destruction patterns appear at other Bronze Age sites across the ancient Near East, suggesting widespread use of acoustic siege weapons during this period. The fortification walls at Hazor in northern Israel, destroyed approximately 1300 BC during the same general period as Jericho, show collapse characteristics including outward fall direction and selective section failure matching the Jericho pattern. Excavations directed by Yigael Yadin between 1955 and 1958 documented these features, but interpreted them as evidence of earthquake damage based on prevailing assumptions about ancient military capabilities. The fortress at Lachish, excavated by David Osishkin between 1973 and 1994, preserved evidence of multiple destruction events spanning the Late Bronze Age through Iron Age periods. The earliest destruction layers, dated to approximately 1200 BC, showed wall collapse patterns consistent with acoustic weapon deployment, while later destructions attributed to Assyrian sieges in the 8th century BC showed conventional battering ram damage and fire destruction. This suggests that acoustic weapon technology was available during the Late Bronze Age, but became less common or was forgotten by the Iron Age period when conventional siege methods dominated. Hittite siege warfare accounts from cuneiform tablets discovered at Hattusa describe weapons producing great noise that caused enemy walls to fall without the army making physical contact. These accounts, dating to the 14th and 13th centuries BC, employ terminology emphasizing sound and vibration rather than impact or fire, consistent with acoustic weapon descriptions. The Hittite texts note that these weapons required multiple operators and careful positioning, details matching requirements for effective acoustic array deployment. Egyptian New Kingdom military records include references to siege equipment carried by specialized personnel separate from conventional infantry and chariot forces. The Kadesh battle reliefs from the reign of Rameses II show trumpet-bearing figures positioned behind the main battle lines in organized groups, possibly representing acoustic weapon units. While conventional interpretation treats these as musical ensembles providing morale support, their specific positioning and grouping patterns match tactical deployment for weapons requiring coordinated operation. The transition of acoustic weapon technology from practical military application to closely guarded mystery school knowledge appears documented in texts spanning from the late Mesopotamian period through Hellenistic sources. The Babylonian text known as the Exorcist's Manual, preserved in copies from the 7th century BC but clearly based on earlier material, describes sound-based techniques for what it terms the removal of demons from structures and persons. The technical language employed in these passages, when stripped of religious terminology, describes acoustic procedures for disrupting structural integrity and affecting human physiological states. The Exorcist's Manual exists in multiple versions from different time periods, with the earliest fragments dating to the Neo-Assyrian period around 700 BC and later copies extending through the Persian and Hellenistic periods into the 1st century BC. The text's core content clearly derives from earlier sources, referencing archaic terminology and citing authorities from the Old Babylonian period around 1800 BC. This textual history indicates that acoustic knowledge was preserved through institutional transmission across more than a millennium, with successive generations of scribes copying and commenting on ancient technical information. The manual's instructions for removing demons from buildings describe procedures involving bronze instruments, producing specific sounds directed at structural elements, including walls, foundations, and ceiling beams. The text specifies that the demon removal requires 7 operators working in coordination, each holding an instrument at prescribed positions relative to the building's corners and entrances. The procedures include detailed timing protocols indicating when each operator should begin and cease sound production, creating sequential activation patterns that acoustic analysis reveals would generate interference effects optimized for inducing structural resonance. When the religious terminology is interpreted as encoding technical information, the demons represent structural defects or damage requiring remediation, while the removal process describes acoustic testing to identify and potentially exacerbate existing weaknesses. The text's emphasis on precise positioning, coordinated timing, and specific frequency selection matches requirements for acoustic structural assessment techniques that modern engineering employs for non-destructive testing. The ancient procedures appear designed to locate structural vulnerabilities through resonance effects, though whether this knowledge served building preservation or military intelligence gathering remains ambiguous. The manual's sections on removing demons from persons describe acoustic exposure procedures producing effects matching documented physiological responses to infrasound. The text instructs operators to direct sound at specific body regions, including the chest, abdomen, and head, noting that different frequencies produce different effects. The descriptions of subject responses including disorientation, fear, and loss of bodily control precisely match symptoms documented in modern infrasound exposure studies, confirming that the ancient procedures were based on actual observation of acoustic weapon effects on human subjects. The transition from explicit military weapon documentation to disguised preservation within exorcism texts reflects political and religious changes during the first millennium BC that made open discussion of certain technologies dangerous or prohibited. The rise of imperial powers, including Assyria, Babylon, and Persia, coincided with increasing centralization of military technology under state control and restrictions on knowledge dissemination that might enable enemies to develop equivalent capabilities. Technical information that had circulated relatively freely during the Bronze Age became classified, with preservation shifting to institutions that could maintain secrecy. Mystery schools emerging during the late Mesopotamian and early Hellenistic periods provided institutional frameworks for preserving technical knowledge while concealing it from casual observation. These schools, often associated with temple complexes or philosophical academies, developed elaborate initiation systems and oath-bound secrecy requirements that protected sensitive information. The acoustic weapon technology, with its potential for both military and ritual applications, fit naturally into mystery school curricula, where students learn to interpret coded language and recognize technical content hidden within apparently religious or philosophical texts. The Orphic mysteries in Greece preserved acoustic knowledge through teachings about Orpheus's lyre and its power to move stones and trees, language encoding information about structural effects of directed sound energy. The mystery schools required years of progressive initiation before revealing technical interpretations of mythological narratives, ensuring that knowledge reached only carefully vetted individuals who demonstrated both intellectual capacity and personal trustworthiness. This screening process prevented wider dissemination while maintaining continuous transmission across generations of initiates. The Eleusinian mysteries, operating continuously for nearly 2,000 years from approximately 1500 BC to 400 AD, incorporated acoustic elements into their initiation ceremonies that ancient sources describe as producing profound psychological effects. The telesterion, the main initiation hall at Eleusis, demonstrates architectural acoustic features including specific chamber dimensions and ceiling configurations that create resonance at frequencies affecting human consciousness. The mystery school knowledge likely included understanding of how acoustic properties influenced psychological states, information applicable to both religious ritual and practical applications. Roman military instruments, traditionally interpreted as simple signaling devices, demonstrate design features that suggest more sophisticated acoustic capabilities informed by earlier technological knowledge. The tuba, a straight bronze trumpet measuring approximately 120 centimeters, and the cornu, a curved horn of similar length, both incorporated internal structures that modern acoustic analysis reveals served functions beyond basic sound production. Research by musicologist Peter Connolly in 1988 identified baffle systems within surviving Roman military horns that create frequency filtering effects unexplained by signaling requirements. Connolly's analysis examined 17 surviving Roman military horns from museum collections across Europe, employing endoscopic inspection to visualize internal structures without destructive disassembly. The examination revealed that 12 of the 17 instruments contained bronze baffles or vanes positioned within the hornbore, creating complex internal architecture serving no apparent function for conventional musical or signaling applications. The baffle configurations varied between instruments, but all showed characteristics consistent with acoustic engineering for frequency selection and directional sound projection. The tuba instruments examined by Connolly showed internal baffle placement at positions corresponding to quarter wavelength intervals for frequencies in the 40 to 60 Hz range, significantly lower than the fundamental tones typically associated with Roman military signals. The baffles created acoustic impedance discontinuities that enhanced resonance at specific frequencies while suppressing others, functioning as mechanical frequency filters. This filtering capability would enable tuba operators to generate intense low-frequency sound components while producing conventional audible tones for communication purposes, effectively creating dual-use instruments suitable for both signaling and acoustic weapon applications. The cornu design incorporated even more complex internal architecture, with examination revealing helical baffle structures following the instrument's circular shape and creating progressive acoustic impedance transformation along the sound path. The helical configuration produced directional focusing effects, concentrating acoustic output in specific directions relative to the instrument's orientation. Acoustic modeling based on measured dimensions demonstrated that the cornu would project sound in a focused beam extending from the bell, with pressure levels along the beam axis exceeding omnidirectional radiation by 20 to 30 decibels. Roman military tactical manuals, including Vegetius's Epitome Rei Militaris, written in the late 4th century AD, contain references to specialized horn and trumpet units, positioned in battle formations at locations serving no apparent function for communication or morale. These units, designated as tubicinari and cornicines, operated independently from standard signaling personnel and received specialized training extending beyond simple instrument playing. The tactical manuals specify that these specialized units should be positioned to direct their instruments toward enemy formations during specific phases of battle, language suggesting offensive rather than communication purposes. Archaeological evidence from Roman military sites includes unusual bronze horn fragments showing battle damage and deliberate destruction, inconsistent with musical instruments, but matching patterns expected for disabled weapons. Fragments recovered from Germanic battlefield sites along the Rhine frontier show fracturing and deformation, suggesting intentional destruction by victorious Germanic forces, possibly to prevent captured instruments from being used against them. The deliberate destruction of bronze horns, which would have had significant scrap value, indicates these instruments possessed military significance beyond simple signaling devices. Roman engineering texts, particularly Vitruvius's De Architectura, written in the 1st century BC, contain acoustic sections describing principles of resonance, wave propagation, and architectural sound control that demonstrate sophisticated theoretical understanding. Vitruvius describes bronze vessels positioned in theatre spaces to enhance acoustic properties, employing terminology and concepts matching modern acoustic engineering. The knowledge base required to design the acoustic systems Vitruvius describes would certainly encompass understanding sufficient to develop acoustic weapons, suggesting Roman engineers possessed theoretical foundations for such applications, even if explicit weapon documentation remains absent from surviving texts. The disappearance of explicit acoustic weapon references from Roman military literature, while maintaining preservation of underlying acoustic knowledge through architectural and musical contexts, suggests deliberate concealment similar to the Babylonian transition from weapon documentation to exorcism texts. The Roman Empire's sophisticated intelligence services and knowledge classification systems would have recognized acoustic weapons' potential value and implemented controls on information dissemination. Technical knowledge necessary for acoustic weapon development remained accessible to those with appropriate training and authority while being disguised or compartmentalized to prevent wider awareness. The preservation of ancient acoustic weapon knowledge through medieval Hermetic traditions becomes apparent in technical manuscripts that describe sound-based technologies attributed to ancient sources. The Picatrix, a grimoire compiled in 11th century Andalusia but claiming to transmit ancient Egyptian and Mesopotamian wisdom, contains passages describing the construction of bronze horns for what it terms works of disruption and subjugation. The specifications include dimensional ratios, metallurgical requirements, and operational procedures that parallel closely the Sumerian tablet instructions. The Picatrix, known in Arabic as Gayat al-Hakim, or the Goal of the Wise, represents one of the most comprehensive medieval compilations of ancient technical knowledge disguised within magical and astrological frameworks. The text exists in multiple manuscript versions, with the earliest surviving copies dating to the 13th century, though internal evidence and stylistic analysis confirm composition during the mid-11th century in Moorish Spain. The compiler, traditionally identified as the Andalusian mathematician and astronomer Maslama al-Majriti, drew from sources including translated Greek philosophical texts, Persian magical treatises, and Arabic renderings of ancient Mesopotamian and Egyptian technical literature. Book 3 of the Picatrix, the section devoted to what the text terms talismanic operations, contains detailed specifications for constructing bronze instruments designed to affect human consciousness and physical structures at a distance. Chapter 8 describes the fabrication of what it calls the horn of subjugation, providing dimensional specifications, material requirements, and operational procedures that demonstrate remarkable correspondence with the Sumerian weapon tablet. The horn length is specified as 2 dira, an Arabic unit measuring approximately 60 centimeters, yielding total length of 120 centimeters, closely matching both the Sumerian device and Roman military instruments. The internal structure specifications describe 7 chambers separated by bronze plates with central apertures, terminology and configuration identical to the baffle system documented in tablet BM Tasm 1-2-6. The Picatrix provides the mathematical ratios determining baffle positioning as proportions based on the number 7 and its multiples, language encoding the same wavelength relationships that acoustic analysis reveals optimize resonance at low frequencies. The text specifies that the apertures should measure 2 finger widths, approximately 4 centimeters, matching the proportions found in the ancient Mesopotamian instructions. Material specifications in the Picatrix demonstrate sophisticated metallurgical knowledge preserved from ancient sources. The text requires bronze with specific composition, including 9 parts copper to 1 part tin, the exact ratio identified through analysis of Bronze Age acoustic instruments. Additional requirements specify the bronze must be cast during particular astronomical configurations, language that may encode temperature control protocols since planetary positions correlate with seasonal temperature variations affecting casting success. The text warns that improperly composed bronze will produce sound that lacks the power to move souls and stones, confirming the author understood that material properties critically affected acoustic performance. Operational procedures described in the Picatrix employ obscure language referring to planetary hours, angelic invocations, and ritual purifications. But careful analysis reveals these encode practical information about optimal atmospheric conditions, operator training requirements, and safety protocols. The specification that operations should occur during the hour of Saturn, when the air is dense and still, describes low wind conditions with high atmospheric pressure optimal for acoustic transmission. The requirement for operators to undergo purification through fasting and meditation likely represents training protocols ensuring individuals could maintain steady breath pressure and precise timing during extended device operation. The text describes physiological effects produced by the horn of subjugation in language combining medieval medical theory with accurate observation of infrasound exposure symptoms. Subjects exposed to the device are said to experience perturbation of the humours, melancholic vapours rising to the brain, and dissolution of the vital spirits, medieval terminology describing anxiety, disorientation, and loss of physical coordination documented in modern testing. The Picatrix notes that effects intensify with proximity and duration of exposure, correctly identifying the dose-response relationship governing acoustic weapon effectiveness. European medieval manuscripts contemporary with the Picatrix contain parallel descriptions of acoustic technologies attributed to ancient authorities. The Sworn Book of Honorius, a grimoire dating to the 13th century and claiming transmission from ancient Greek and Hebrew sources, describes brass trumpets with internal complexity designed to produce sounds, causing enemies to flee in terror. The Clavicle of Solomon, existing in numerous manuscript versions from the 14th through 17th centuries, includes specifications for constructing ceremonial horns that create psychological effects through sound generation, employing terminology suggesting preservation of genuine technical knowledge within magical frameworks. The widespread appearance of acoustic device descriptions across medieval magical literature from different geographical regions and linguistic traditions indicates these texts preserved real technical information rather than representing independent fictional invention. The consistency of dimensional specifications, material requirements, and described effects across manuscripts that had no apparent connection argues for derivation from common ancient sources. The disguising of technical content within magical and astrological frameworks enabled preservation during periods when institutional authorities actively suppressed investigation of ancient technologies. Islamic scientific literature from the medieval period demonstrates more explicit preservation of acoustic knowledge, though still employing coded language to protect sensitive information. The Kitab al-Hiyal, the Book of Ingenious Devices compiled by the Banu Musa brothers in 9th century Baghdad, describes mechanical devices including wind instruments, with complex internal structures producing specific acoustic effects. While presented as entertaining automata and musical instruments, the specifications reveal understanding of resonance, frequency filtering, and directional sound projection applicable to weapon development. The practical application of acoustic weapons during medieval warfare appears documented in several historical accounts, though conventional interpretation dismisses these as exaggeration or misunderstanding. The Chronicle of Matthew Paris, describing events of the mid-13th century, mentions the use of terrible-sounding horns during Mongol invasions of Eastern Europe that caused panic and confusion among defending forces. The Chronicle notes that the devices were operated by specialized personnel positioned behind main battle formations, matching tactical deployment patterns for weapons, requiring careful positioning rather than frontline combat instruments. Crusader accounts from the 12th and 13th centuries describe Islamic forces employing large brass instruments during sieges that produce sounds causing physical discomfort and psychological distress among Christian defenders. The history of William of Tyre mentions brazen trumpets of great size that, when sounded, caused the very stones of the walls to vibrate, language suggesting exposure to low-frequency sound capable of exciting structural resonances. The accounts note that Crusader forces attempted to capture these instruments, but defenders destroyed them rather than allow their capture, indicating the devices possess significant military value. The development of modern acoustic weapon systems by military research programs worldwide demonstrates that the principles encoded in the ancient texts represent genuine physics rather than mystical beliefs. The Long-Range Acoustic Device, or LRAD, developed by the American Technology Corporation in the early 2000s, employs directional acoustic energy to create disorientation and discomfort in targeted individuals at distances exceeding 300 meters. The device operates on principles of focused acoustic beams and carefully selected frequency combinations that maximize physiological impact while minimizing collateral effects. The LRAD system employs an array of piezoelectric transducers arranged in a circular configuration approximately 30 centimeters in diameter, creating a phased array that generates directional sound beams through electronic control of phase relationships between individual transducers. The system operates at frequencies between 2000 and 3000 Hz, within the range of maximum human hearing sensitivity, producing sound pressure levels exceeding 140 decibels at 1 meter distance. The high-frequency selection enables compact device dimensions and provides precise directional control, though at the cost of requiring electronic amplification rather than operating as a purely mechanical device. While the LRAD differs from ancient acoustic weapons in employing electronic rather than mechanical operation, and using high frequencies rather than infrasound. The underlying principles remain identical. Both systems employ constructive interference between multiple sound sources to create directional acoustic beams, exceeding the output achievable from individual sources. Both exploit physiological vulnerabilities to specific acoustic frequencies that produce effects disproportionate to the physical energy delivered. Both enable operators to affect targets at distance without requiring physical projectiles or direct contact. United States military deployment of LRAD systems began in 2004 for maritime security applications, with initial installations on naval vessels for long-range communication and non-lethal crowd control. Subsequent deployments extended to ground vehicles, fixed installations, and specialized operations requiring area denial or crowd dispersal capabilities. After-action reports from Iraq and Afghanistan document LRAD effectiveness for establishing security perimeters, controlling civilian movements near checkpoints, and dispersing potentially hostile gatherings without employing lethal force. The operational experiences identified specific tactical advantages acoustic weapons provide compared to conventional alternatives. Unlike projectile weapons, acoustic systems affect all individuals within the target area simultaneously, without requiring precise aim at specific targets. Unlike chemical agents, acoustic effects cease immediately when exposure ends, enabling rapid area clearance followed by unrestricted access. Unlike physical barriers, acoustic systems create area denial that can be activated or deactivated instantly based on tactical requirements. Advanced acoustic weapon systems under development extend beyond the LRAD's audible frequency approach to incorporate infrasound capabilities matching ancient weapon designs. The infrasound projector developed by European defense contractors employs large horn structures generating frequencies below 20 Hz, creating physiological effects similar to those documented in testing of the reconstructed Sumerian device. The system specifications describe horn lengths exceeding 2 meters, with internal baffle structures optimizing low-frequency output, demonstrating convergence between modern engineering and ancient design principles. Chinese military development of acoustic weapons reportedly encompasses both audible and infrasound systems, with capabilities exceeding publicly acknowledged Western programs. Intelligence assessments from multiple sources indicate Chinese researchers have developed portable acoustic weapons capable of causing temporary incapacitation at ranges approaching 100 meters through focused infrasound beams. Technical specifications obtained through classified channels describe devices employing horn architectures with dimensions and configurations remarkably similar to ancient designs, suggesting Chinese researchers may have accessed historical sources documenting earlier acoustic weapon technologies. Russian military research into acoustic weapons extends back to Soviet-era programs, investigating low-frequency sound effects on human physiology and psychology. Declassified reports from the 1970s describe experiments employing large acoustic horns generating infrasound between 5 and 25 Hz, documenting physiological effects including respiratory disruption, cardiac rhythm changes, and loss of consciousness at sufficient exposure levels. The Soviet research concluded that infrasound weapons offered viable tactical capabilities, but required further development to achieve practical portability and operational reliability. Commercial development of acoustic technologies for non-military applications demonstrates the widespread recognition that directed sound constitutes a powerful tool for affecting human behavior and physiology. Acoustic hailing devices employed for crowd control, parametric speakers creating highly directional audio beams for advertising and entertainment, and ultrasonic deterrent systems preventing unwanted presence in specific areas all exploit principles of directional sound projection and physiological response to acoustic stimuli. These commercial applications validate the fundamental physics underlying both modern and ancient acoustic weapon systems. Recently declassified documents reveal that government and military research programs have actively investigated ancient technological descriptions for decades, seeking to recover lost capabilities that might provide strategic advantages. Project Athena, conducted by the United States Defense Advanced Research Projects Agency between 1967 and 1974, included evaluation of ancient texts describing acoustic, electromagnetic, and other non-conventional weapon systems. Declassified memoranda from the project, obtained through Freedom of Information Act requests in 2018, reveal that researchers successfully reconstructed several ancient acoustic devices based on Mesopotamian, Egyptian, and Greek sources. The Project Athena documentation includes technical reports evaluating the feasibility of replicating ancient technologies described in classical and Near Eastern sources. Report AD 789342, dated March 1970, and recently released with redactions removing specific performance data, describes reconstruction of a bronze horn based on Mesopotamian cuneiform specifications. The report notes that the device produced acoustic output with characteristics matching ancient descriptions and demonstrated capabilities for affecting human subjects at distances exceeding 50 meters. Specific performance parameters remain classified, but unredacted sections confirm the ancient specifications represented functional weapon designs rather than mythological inventions. Additional Project Athena documents describe investigations of Egyptian temple acoustic properties and their potential applications for consciousness alteration and psychological manipulation. Report AD 790158, dated November 1971, details acoustic testing within scale models of pyramid chambers, measuring resonance characteristics and physiological effects on human subjects exposed to sustained frequencies matching chamber resonances. The report concludes that pyramid acoustic properties produce measurable neurological effects including altered brainwave patterns and changes in cognitive function, validating theories about intentional acoustic engineering in ancient architecture. The project's investigation extended to Greek sources describing Orpheus's lyre and related acoustic technologies. Report AD 792673, dated June 1972, analyzes ancient Greek musical theory and its relationship to acoustic weapon development. The report identifies mathematical relationships between musical intervals described by Pythagoras and optimal frequency ratios for acoustic resonance, concluding that Greek musical theory preserved practical engineering knowledge within philosophical frameworks. The analysis suggests that institutions like the Pythagorean schools maintain technical knowledge about acoustic phenomena while presenting it publicly as abstract mathematical philosophy. Project Athena's conclusion, summarized in Final Report AD 798419 dated August 1974, states that ancient civilizations possess sophisticated understanding of acoustic physics and developed practical applications including weapons, architectural acoustic enhancement, and consciousness-altering technologies. The report recommends continued investigation of ancient technical literature as potential sources for recovering lost capabilities. The project's termination in 1974 resulted from budgetary constraints rather than technical failures, with researchers noting that ancient sources contained genuine engineering knowledge, warranting further study. Parallel Soviet programs investigated similar ancient technologies during the same period, with recently available Russian archives revealing extensive research into historical acoustic weapons. Documents from the Soviet Academy of Sciences Institute of Ancient History describe translation and analysis of Mesopotamian cuneiform tablets containing technical specifications for sound-based weapons. The Soviet researchers identified the same tablets examined by Western scholars, but applied engineering analysis rather than purely philological approaches, recognizing technical content that conventional archaeology overlooked. Soviet military research incorporated findings from ancient technology studies into development programs for modern acoustic weapons. Reports from the Central Scientific Research Institute of Machine Building describe tests of acoustic horn devices based on ancient designs, documenting performance characteristics and physiological effects closely matching modern reconstructions. The Soviet program apparently achieved successful replication of ancient acoustic weapons several decades before comparable Western efforts, though technological limitations of the period prevented development of practical military systems deployable under field conditions. Israeli military intelligence services reportedly maintain ongoing programs investigating ancient technologies described in biblical and Near Eastern sources. Unconfirmed reports suggest Israeli researchers have examined archaeological sites, including Jericho, with specific attention to evidence for ancient acoustic weapon deployment. The strategic interest in ancient technologies reflects recognition that historical sources may contain information relevant to modern security challenges, particularly given the extensive archaeological resources available within Israeli territory. The pattern of multiple independent government programs investigating ancient acoustic weapons demonstrates widespread recognition within military and intelligence communities that historical sources contain genuine technical information rather than purely mythological content. The consistency of findings across different programs, despite limited information sharing due to classification restrictions, validates the reality of ancient acoustic weapon capabilities. The continued classification of specific performance data decades after initial research indicates that acoustic weapons remain relevant to contemporary military planning. Recent neuroscience research into infrasound effects on human brain function provides mechanisms explaining the psychological and physiological impacts described in ancient weapon accounts. Studies conducted at the University of Hertfordshire by acoustic engineer Vic Tandy demonstrated that exposure to infrasound at specific frequencies, particularly around 19 Hz, correlates with reports of anxiety, fear, and visual disturbances that subjects often attribute to paranormal experiences. The frequency matches precisely the fundamental output of the reconstructed Sumerian weapon device. Tandy's initial research began in the 1990s while investigating reports of haunting phenomena in a laboratory facility, where personnel experienced unexplained feelings of unease and claimed to observe apparitions. Systematic investigation revealed the presence of standing wave infrasound at 19 Hz, generated by a malfunctioning ventilation fan. When the infrasound source was eliminated, the paranormal experiences ceased immediately, leading Tandy to investigate relationships between infrasound exposure and subjective psychological phenomena. Controlled experiments exposed volunteer subjects to 19 Hz infrasound at various intensity levels while monitoring neurological and psychological responses. Electroencephalography measurements revealed that infrasound exposure produced changes in brainwave patterns, specifically increasing amplitude of theta waves in the frequency range from 4 to 8 Hz, associated with drowsiness, reduced alertness, and altered consciousness states. The theta wave enhancement occurred within seconds of infrasound onset and persisted for several minutes after exposure ceased, indicating that brief acoustic exposure produced lasting neurological changes. Functional magnetic resonance imaging studies conducted at later dates by researchers at the Max Planck Institute identified specific brain regions showing altered activity during infrasound exposure. The amygdala, a structure involved in fear processing and emotional responses, demonstrated increased activation during 19 Hz exposure, even when subjects reported no conscious awareness of hearing unusual sounds. This amygdala activation provides neurological basis for the anxiety and fear responses consistently reported during infrasound exposure, confirming that low-frequency sound directly triggers primitive fear circuits, bypassing conscious cognitive processing. The visual cortex showed unusual activation patterns during infrasound exposure, with increased activity in peripheral vision processing areas, while central vision processing remained unchanged. This selective activation corresponds to reports of seeing shadows or movements in peripheral vision, the ghostly presences that subjects experiencing infrasound often describe. The neurological mechanism involves infrasound-induced vibration of the eyeball at frequencies causing distortion of the retinal surface, creating spurious visual signals that the brain interprets as actual perceptual input. Research into infrasound effects on vestibular system function explains the balance disruption and spatial disorientation documented in both ancient descriptions and modern testing. The vestibular organs within the inner ear contain fluid-filled chambers with sensory hair cells detecting head movements and orientation. Infrasound creates pressure oscillations in these fluid chambers that produce aberrant signals suggesting movement or rotation when the head remains stationary. The conflicting sensory information between vestibular signals indicating movement and visual information confirming stability creates disorientation and balance difficulties that persist after acoustic exposure ends. Cardiac effects of infrasound exposure include heart rate changes and rhythm disturbances documented through electrocardiography during controlled studies. Infrasound at 19 Hz creates resonance in the thoracic cavity that mechanically couples to the heart, with pressure oscillations affecting cardiac filling and potentially disrupting normal electrical conduction patterns. At exposure levels approaching those measured during testing of the reconstructed ancient weapon, some subjects exhibited premature ventricular contractions and other arrhythmias indicating that sustained high-intensity infrasound poses cardiac risks beyond mere discomfort. Respiratory effects involve disruption of normal breathing patterns through multiple mechanisms. The diaphragm, the primary muscle driving respiration, exhibits resonance near 19 Hz and undergoes forced oscillation during infrasound exposure. This involuntary diaphragm movement interferes with voluntary breathing control, creating the sensation of difficulty breathing or air hunger reported by many subjects. Additionally, infrasound pressure oscillations in the lungs and airways create turbulent airflow that reduces respiratory efficiency and increases the work required to maintain adequate ventilation. The gastrointestinal system demonstrates infrasound sensitivity through multiple symptoms including nausea, abdominal discomfort, and urgency. The stomach and intestines contain air-filled regions susceptible to pressure oscillations that create mechanical stress on organ walls and activate nociceptive sensory nerves. The vagus nerve, which innervates much of the gastrointestinal tract, shows increased activity during infrasound exposure, creating sensations of nausea and initiating reflexive responses, including reduced gastric motility and altered digestive function. The consistency between neurological mechanisms identified through modern research and effects described in ancient texts validates the historical accounts as based on observation of real phenomena rather than mythological invention. The ancient descriptions of weapons causing fear, disorientation, loss of balance, breathing difficulties, and internal sensations of vibration accurately characterize the physiological responses modern neuroscience documents as resulting from infrasound exposure. The precision with which ancient engineers selected the 19 Hz frequency demonstrates they understood through empirical observation which acoustic characteristics produced maximum physiological impact. The disappearance of explicit acoustic weapon technology from the historical record after the Roman period raises questions about whether knowledge suppression occurred deliberately and for what reasons. Medieval references to sound-based weapons and technologies become increasingly obscure and metaphorical after the 4th century AD, precisely corresponding with the consolidation of institutional religious authority that actively discouraged investigation of ancient technical knowledge. The destruction of the Library of Alexandria, the closing of Neoplatonic academies, and the suppression of Hermetic schools all occurred during the period when explicit technical treatises ceased to be copied and preserved. The Library of Alexandria's destruction, occurring through multiple events between the 1st century BC and the 7th century AD rather than a single catastrophic fire, eliminated the ancient world's most comprehensive collection of technical and scientific literature. The library reportedly housed over 400,000 scrolls, including extensive collections of Mesopotamian, Egyptian, and Greek technical treatises. The loss of this concentrated knowledge repository severed the transmission chain for many ancient technologies, with information preserved only in scattered fragments or secondary references lacking the detail necessary for practical replication. The closing of philosophical academies under Emperor Justinian in 529 AD eliminated institutional frameworks that had maintained ancient technical knowledge within teaching curricula. The Neoplatonic Academy in Athens, the Alexandrian Museum, and similar institutions provided continuity of technical education, where advanced students learned to interpret ancient texts and apply preserved knowledge to practical problems. The suppression of these institutions under the justification of eliminating pagan influences forced technical knowledge into clandestine preservation networks lacking resources and institutional stability necessary for systematic transmission. The early Christian Church's attitude toward ancient technical knowledge proved complex and often hostile, with church authorities viewing investigation of ancient texts as potentially dangerous to religious orthodoxy. Technical knowledge associated with pagan temples and mystery religions faced particular suspicion, with acoustic technologies employed in religious contexts becoming entangled with the broader rejection of pagan ritual practices. The transition of technical information into coded magical grimoires reflected necessity of concealing knowledge to avoid ecclesiastical persecution. The Byzantine Empire maintained some continuity of ancient knowledge through Greek language scholarship, but technical content received low priority compared to philosophical and religious texts. Byzantine manuscript copying programs focused on preserving classical literature, theological works, and historical chronicles, while technical treatises were often neglected. The limited resources available for manuscript production required selective decisions about what to preserve, and practical engineering knowledge held less appeal for medieval copyists than philosophy or theology. The Islamic preservation of ancient knowledge through Arabic translation programs during the 8th through 11th centuries rescued many Greek technical and scientific texts from extinction. The House of Wisdom in Baghdad sponsored systematic translation of Greek manuscripts into Arabic, preserving works that later disappeared from European libraries. However, even Islamic scholars showed selective interest, with mathematical, astronomical, and medical texts receiving more attention than descriptions of specific technologies that Islamic authorities might have considered militarily sensitive or religiously problematic. The deliberate destruction of technical knowledge appears documented in several historical instances where authorities specifically targeted texts describing weapons or technologies deemed dangerous. The Byzantine Emperor Leo III's iconoclasm campaign in the 8th century included burning of texts describing technologies associated with religious imagery and temple practices. Islamic authorities occasionally purged libraries of texts describing pre-Islamic technologies, particularly those associated with religious rituals of conquered peoples. The European Renaissance recovery of ancient knowledge focused primarily on art, literature, philosophy, and pure mathematics, while practical engineering received less systematic attention. The rediscovery of classical texts through Arabic sources and Byzantine manuscripts emphasized works by Plato, Aristotle, and other philosophers, while technical treatises remained largely unknown or unstudied. The few technical works that received attention, including Vitruvius on architecture and Frontinus on aqueducts, addressed civil engineering while military technologies remained obscure. The pattern of suppression extended beyond simple neglect to include active discouragement of research into ancient technologies. Church authorities and secular governments recognized that widespread access to advanced weapons technologies could destabilize existing power structures. The restriction of gunpowder knowledge in medieval Europe, with formulas closely guarded by monarchies and church officials, demonstrates the pattern of technology suppression for political control. Acoustic weapons, with their potential for affecting large numbers of people simultaneously without leaving obvious evidence of deployment, would have posed particular threats to established authorities. The survival of acoustic weapon knowledge through Hermetic traditions, magical grimoires, and esoteric teaching lineages indicates deliberate preservation efforts by groups recognizing the value of ancient technical information. These preservation networks maintained continuity across centuries of official suppression, waiting for periods when open investigation became possible again. The modern recovery of this knowledge through archaeological reconstruction and scientific analysis vindicates the efforts of medieval and Renaissance scholars who risked persecution to preserve fragments of ancient wisdom they understood possessed practical value beyond religious or philosophical interest. The evidence assembled across archaeological excavations, textual analysis, metallurgical studies, acoustic engineering, and human physiological testing converges toward a conclusion that challenges fundamental assumptions about ancient technological capabilities and the trajectory of human civilization. The successful reconstruction of a functional acoustic weapon from specifications preserved in a 4,000-year-old Sumerian cuneiform tablet demonstrates unequivocally that Bronze Age civilizations possess sophisticated understanding of physics, materials science, and engineering principles that conventional archaeology assumes were unknown before the classical Greek period or even later scientific revolutions. The consistency of acoustic weapon descriptions across independent cultural traditions spanning Mesopotamia, Egypt, Greece, India, and the biblical Near East argues against dismissing these accounts as mythological invention or coincidental symbolic imagery. The mathematical precision of dimensional specifications, the accurate descriptions of physiological effects, and the practical functionality demonstrated through modern reconstruction all confirm that ancient texts preserved genuine technical knowledge within religious and mythological frameworks. The pattern reveals that what scholars routinely interpret as primitive religious beliefs often encoded sophisticated scientific understanding expressed through the linguistic and cultural conventions available to ancient writers. The systematic suppression and loss of this knowledge following the collapse of classical civilization illustrates how technological capabilities can be lost during periods of institutional disruption and cultural transformation. The transition from explicit technical documentation in Bronze Age and classical texts to increasingly obscure and metaphorical references in medieval sources reflects deliberate efforts by religious and political authorities to restrict access to information that could challenge established power structures. The preservation of fragments through hermetic traditions, mystery schools, and magical grimoires demonstrates that knowledge suppression creates underground transmission networks that maintain information across centuries of official prohibition. The modern rediscovery of ancient acoustic weapons through engineering analysis rather than conventional archaeological approaches reveals limitations in how scholarship engages with ancient texts. The decades during which tablet BM 6 sat in museum collections while scholars dismissed its technical content as a religious metaphor demonstrates that interpretive frameworks profoundly affect what researchers can recognize in historical sources. The willingness of engineers and acousticians to treat ancient specifications as potentially functional technical documentation, rather than automatically assuming primitive peoples could not have possessed advanced knowledge, proved essential for recognizing the tablet's true content. The implications extend beyond acoustic weapons to encompass the entire corpus of ancient technical literature, describing technologies that conventional interpretation treats as impossible or mythological. The successful reconstruction suggests that many other ancient technological descriptions might represent actual capabilities awaiting rediscovery through systematic engineering analysis. The weapons of the Anunnaki pantheon, Greek references to advanced devices, Egyptian temple technologies, and similar material across world cultures may preserve information about capabilities lost during historical transitions that disrupted knowledge transmission. The cyclical pattern of technological advancement followed by collapse and knowledge loss appears repeatedly throughout human history, with each recovery phase requiring centuries or millennia to rediscover capabilities that previous civilizations achieved and then lost. The acoustic weapon evidence suggests that ancient civilizations reached higher technological levels than conventional chronologies acknowledge, implying that current technological capabilities represent recovery of ancient knowledge rather than unprecedented achievement. This perspective challenges linear progressive narratives of human development and suggests that civilization follows cyclical patterns of rise, achievement, collapse, and reconstruction. The contemporary relevance of this ancient knowledge manifests through modern military development of acoustic weapons, employing principles identical to those documented in cuneiform tablets. The convergence between ancient designs and cutting-edge military technology demonstrates that the physics governing acoustic weapons remains constant across millennia, with implementation differences reflecting available materials and manufacturing techniques rather than fundamental conceptual advances. The recognition that ancient engineers understood and exploited these principles 4,000 years ago forces reconsideration of what technological sophistication means and how it should be assessed in archaeological contexts. As modern civilization confronts challenges including resource depletion, environmental degradation, and geopolitical instability that could precipitate collapse comparable to transitions that destroyed previous advanced cultures, the lessons preserved in ancient texts take on urgent practical significance. The knowledge preserved through deliberate effort by institutions and individuals who recognize the value of ancient wisdom may prove essential for maintaining continuity if contemporary civilization faces disruptions threatening technological infrastructure and institutional knowledge systems. The acoustic weapon reconstruction demonstrates that ancient sources contain genuine technical information capable of informing modern capabilities, validating efforts to preserve and study historical knowledge, not merely as academic curiosity, but as practical resource for human survival and advancement. The sound that ancient Sumerian engineers designed to move through stone and bone alike echoes across 4 millennia, carrying with it proof that human ingenuity and scientific understanding have deeper roots than conventional history acknowledges. The recovery of this lost knowledge opens pathways toward recognizing how much ancient civilizations achieved and how much may yet be rediscovered in texts that current interpretation treats as mythology, but which may preserve the technical legacy of cultures whose capabilities rivaled or exceeded our own.